Good evening everyone, क्या हाल चाल? Hopefully every one of you is doing absolutely fantastic. Welcome your chemistry expert Sanjay Arya sir. We have an amazing session today right before the day of your exam. Those who are going to appear in 28th of January and 29th of the January. Okay, so I have come up with this amazing content of like observation among 22, 23 and 24, and what I want to project you about the 28 and 29 shifts of January. We'll be solving some hundreds of the questions and we'll try to make and boost our confidence in chemistry very well. So those who are right now watching this lecture, guys, only stay focused about solving. Don't you just get involved into so many concepts right now and just completing and revising everything. No, it's all done before. Let's solve some question. Make focus how the questions have been asked. What is the procedure to solve them? Even I won't take too much of your time to let you understand how to solve the question, and then we'll move forward to the final our evaluation, and what we have to do, that strategy will be revealed. You all know me. My name is Sanjay Arya. Been teaching from past 10 years. I have qualified IIT JEE exam in 2010 exam, and right after that I have completed my graduation and being engaged in serving all the students, letting them reaching to their aims and their targets of this very amazing journey of JEE Mains and Advanced. So we'll take you right now directly to some one of the analysis. Okay, so before reaching to a question, I would like to give you the analysis of when did we start? We started 22nd, 23rd, and then we reached to 24th of the January. Okay, we are right now in 2025. So guys, there were 3 shifts we all had, and out of these all 3 shifts, what we had is first of all, I like to mention those chapters which were asked in like very dominating amount, we must say. So first of all, I must say the most frequently asked so these are the number of chapters which were most frequently asked. Number 1, the one I saw and I found it is in like too much of the questions have appeared from the that chapter. So in the first shift we saw atomic structure as the dominant part. We also saw some of the questions from biomolecules very dominantly came in all the shifts. One each, 1 and 2 questions come. I remember in atomic structure 2 questions came directly from the topic. Then also chemical bonding was there, but some part of chemical bonding was missing that I found. So chemical bonding, specifically VSEPR theory and its application were there. So that's what happened on 22nd of the January, 23rd, 4th. For these 3 days. Apart from these, I also found coordination, DNF block elements. First of all, DNF block plus coordination were asked in plenty. So many questions appeared, and coordination compounds came up with VBT, CFT, even Werner theory questions were there. So this is something that kept on coming repeatedly. If I talk about the organic chemistry, I found majority of aldehyde, ketone, carboxylic. Then we had amines in very domination. Amines was asked very frequently. Too many questions were there of amines. So, okay, so these much number of actually questions appeared, and these much chapters were appearing frequently back to back. But something that was missing, I would like to give you an idea that this is something which didn't come. So basically these are the chapter which didn't come. So what chapter were there which were not asked, which are quite important chapter, and they must have been asked with a, you know what, like so many questions have come earlier, but I saw lacking. Only one shift was there. I remember there was only one shift. Let me take that pen only. That was working well. Yeah, where was on 23rd only. This was the only shift where thermodynamics was used. but majority of the concepts of thermodynamics were missing. So thermochemistry and thermodynamics, something that can be used, didn't come very frequently, and yeah, we must say that rarely asked. So now I am just thinking in this way that the probability of asking these questions have increased. If we ask about thermodynamics, if we talk about one important part of general organic chemistry, and specifically if I talk about the reaction mechanism part, SN1, SN2 wala part, isomerism was there, but some of the isomerism part was missing. But most importantly, I found that chemical bonding was missing in terms of molecular orbital theory, wasn't used frequently. So now it will be coming in your 28th and 29th shift, that what I found. And I also think that there should be some more questions from ionic equilibrium. I saw some of the questions from chemical equilibrium, and that chemical equilibrium questions were in plenty, but I didn't see any question from ionic equilibria. Now that's something that has to be asked. Yeah, few questions were seen in terms of solubility and solubility product, but questions from buffer solution, questions from the salt hydrolysis and finding the pH of the solution, and these kind of concepts were missing, which are major concept I find. So there is a possibility that these much number of chapters may appear in your upcoming 28 and 29 shift, but still, now this is something that I have observed in my own opinion, and this may vary with the different teachers and different point of view and different student as well. So guys, my overall suggestion is, considering everything in the account, considering everything in our mind, we have to be focused about what is gonna to ask, how are we gonna to appear in the paper, rather than thinking that this may come or may not come, should I cover this part of the chapter or should not. So that is secondary thought must not come in our mind. So for this whole year, whatever we have learned today here, whatever the topic we have covered or chapter we have covered, stay confident about the topic and attend it very what should I say, very bravely. So show your bravery in this exam and just move forward, and then you will be getting selected about whatever the thing you are objective and planning for. So that's what I had, and now I'll give you some 100 of the questions, and I have included all the part of these topics as well which were missing, and this topic which were already asked is also there. So I've just made the 100 question in such a way, more or less I'm giving more number of questions to the topics which were missing, and just decreasing a few number of questions from the one which has already been asked in the very domination part. So now we'll come and just try to understand the remaining agenda of this particular concept. Now we'll be starting our session. Hopefully I'm pretty much visible to every one of you. So we'll start it from the first question. This is your atomic structure itself, but questions came from these topic, and some of the questions are very important, talking about their concepts of de Broglie, asked earlier as well and maybe asked in your upcoming shifts as well. Question is pretty simple. De Broglie wavelength of electron moving in third excited state. So you always must remember some of the facts, how come these things are related like that. So it's saying that de Broglie wavelength of an electron moving in third excited of helium will be what? So guys, you all must know, first of all, you must know with the R0, which is the radius of hydrogen for n is equals to 1, and we call it the ground shell, and that is actually 0.529 n square by z. We call it n square by z. So that's the formula we'll use. Okay, it's very easy thing. So let me not just okay, we won't take too much of your time. You keep on practicing with me, try to find out your answer and submit me in the comment section. If you face any kind of doubt, do let me know. I'm right now continuously watching your doubts as well. This formula we have to apply, so we have to find out a radius for helium positive, and we have to use its number of shell as third excited. You know, it is the meaning of third excited means n plus 1 you have to do. 3 plus 1 will be fourth state it has been asked. So do it. N square by z, so 0.529, and we'll write 4 square divided by z is actually hydrogen helium 2. So this is 0.529 multiplied by 8 angstrom is the correct answer. Don't even require to solve up with. You can do it by your own. I know you all are pretty comfortable solving it. I guess A is the correct answer. What do you think? So C is the correct answer. Okay. Anyways, you'll find it. C is the correct answer. MBR is equals to, but what we are given up with, we have R, we have to find out, and actually D Broglie wavelength was asked, we unnecessarily found out the radius, no problem, but there's one more thing that we can do, that n lambda is equals to 2 pi r. So n lambda is equals to 2 pi r, n also represents the number of shell, so it is equals to 4, and r is something that you already have calculated. So now using this you can find out the lambda will be equals to 2 pi into the same thing, which is 0.529 into 8 divided by what? 4. So this is 1 ja, this is 2 ja. Now it will give you the correct answer. So that's what we did. This is what it is given. Lambda is equals to h by mv. MBR is equals to nh upon 2 pi. We solved it and then we got the answer. That's the same thing which we are doing. Okay, it's exactly the same thing what we are doing. So you can solve it. 2 into 2 is 4 into this will be, I guess, 2.12. This is exactly the same answer we are getting. Now let me take you to the next question. Let's see the next question. Probably one other important reaction we have. Question is based upon 2 liter of 0.2 molar H2SO4. Okay, these kind of questions came also, and there is a high probability of being asked for these questions. I personally think so. So we'll try to solve it quickly. We have two things. Such of kind of question may appear you. We have to just look at the frame and like the reference I'm talking about. This question somehow looks like this. We got to know what chemical reaction is there between acid and base, making sure we are properly using their balanced chemical equation. Or there's one more thing which we can do. We can also use their gram equivalents, and then we can calculate what we are required for. So H2SO4 NaOH is there, and this will produce Na2SO4 plus 2 times of water will be formed. Now out of this given equation, we know that at time equals to 0, how many liter is given? 2 liter and 0.2 molar. Just simply do 2 liter into 0.2 and you will be getting 4.4 moles. This is getting us 0.4 moles, and the same we're gonna to do it for 0.1 into 2 liter. So this is also gonna to give us 0.2 moles. But when the T time will come, the limiting reagent will be consumed completely, and we all know 2 moles of this will be consumed and 1 mole of this is required. If 0.2 is there, 0.1 moles required. This has become an access reagent. This will become a limiting reagent by simple calculation. 0.2 will be completely consumed, so will be remaining 0. When we 0.2 moles of this will be consumed, it will be remained with half of the moles of 0.2 will be consumed, so it will be remaining with 0.3. We can also do it like 0.4 minus how many moles of this will be consumed? The one which is consumed by NaOH divided by 2, so this will become 0.3. Now everything is with you. You know the number of moles, you know the formula of molarity for Na2SO4. So the molarity will become what? Number of moles divided by, no, not this. Actually, we have to find it out for Na2SO4. So Na2SO4 will be produced how much? So from there we will be getting, this is also as 0.2 moles, not 0.2, 0.1 moles. 2 moles of NaOH produces 1 mole of Na2SO4. 0.2 will produce 0.1 mole. Simply use the data and find out the molarity. 0.1 divided by total volume is how much? 2 plus 2 is 4, and that's how you get your answer. Let's see the correct answer, everyone. We get 25 ml. That's how we get the correct answer. Now I'll take you to the next question. We have the next question, everyone. Bohr theory. So many questions from Bohr already have come, and I have a probability upon coming these questions with. But again, if not this question, then there could be a question from modern mechanical model, wave mechanical model, because very lesser questions came till now from atomic structure from that portion. So the one I explained you, that was a chapter wise segregation, but if I go inside deep dive over there, we'll find there were so many topics that kept untouched by JEE. So there is a possibility of being asked for these topics in 28 to 29. But again, coming to the fact that all the questions should be done from our end very freely, very flawlessly, rather than being very dominant and very much biased toward the question not required. Another question, kinetic energy of the electron is Z square by N square, which is true. Product of velocity. Velocity is directly equal to z by n into principal quantum number is n. So that will be directly proportional to the. So Vn, V is z square by n square. That will be directly equal to z cube actually. No, z square by n, not z square. So this is incorrect. And then we have another thing, frequency of revolution. You know, frequency of revolution 1 by time period. Time period is distance upon velocity. Distance is 2 pi r upon velocity. So 2 pi r is directly equal to n square by z upon z by n. So it will become n cube by z. So reversing that, z square by n cube. Okay. So I think this is false. But Coulombic force, k q1 q2 by r. So k q1 q2 by r. So more or less we are upon r is square. So this is like force is directly equal to 1 by r is square, and r is directly equal to what? Z square by n. Z square by n. So you will do it square and will replicate it. Then the Coulombic force of electron will become how much? Okay, that is also equals to k q1 q2 by r square. So force is actually k into q1 charge is actually charge of an electron, and q2 charge is of the nucleus. So yes, it will require one more z here, z times of e. So then solving this whole, it will give you a directly proportionally to, I guess, z cube. One z will be cancelled out, and no, z cube, and then n raised to power 4 will be there. Na 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 na. And most of the so this is a true statement. Choose the most appropriate answer. Okay, that's it. I guess A and D. A and D is fine. Okay. Next question related to the what should I say? These questions are for quantum number, and I personally find that JEE will prefer to ask questions from quantum number, because till now not so many questions have been asked from quantum number. So the principal quantum number n is positive integral value, which is true, and then azimuthal quantum number L for a given principal quantum number can have values of 0, 1, 2, 3, 0, 1, 2. That is also true up to n minus 1. Sorry, this is incorrect because it has up to what? N minus 1. So that is a false statement. Then magnetic quantum number has a particular value for 2L plus 1, which is true. Minus L2 plus L has an integral value of 2L, integral values only, negative to positive. Then we have positive half and minus r are two possible states of the orientation, true. Then we also have this L equals to 5, then total, there will be a total of 9 orbital. So for L is equals to 5, if L is equals to 5, what subshell we are talking about? See, 0 SPD 0 say S, SPD FGH. So this has H subshell. So what has to be find out? Orbital. So 2 times of L plus 1. Number of orbitals will be, number of orbitals are with the total possible values of M. That is 2 in square. That is 2L plus 1. 2 into 5 plus 1. 11 should be the correct answer. So this is also incorrect. This is also false statement. So we can check out the correct one. I think A, C and D, C. So that's it. That is what we have to take in our mind rather than just rote learning the questions. Simply apply the focused concept and that will give you more basically, I must say, the idea. Okay. Next question is the correct graph representing the electron gain enthalpy of chalcogens. Who are chalcogens, by the way? Who are chalcogens? So we know chalcogens are, who are chalcogens here? Halogens, something before, I think oxygen, sulfur, selenium, tellurium, polonium. That is what we are having. Chalcogen, oxygen, sulfur. Only oxygen, sulfur, selenium we have to consider. Okay, oxygen, sulfur, selenium. So this is being the smallest in size, and it also has the lowest electron affinity. Okay, amount of energy we are talking about in magnitude probably over here. So delta Eg is actually is the released energy. So actually we have to take this thing in positive value only. So magnitude we are talking about, it's already released actually. So the correct answer should be oxygen come up at the smallest, and this has the highest among all, because we all know the electron affinity of third period elements is more. Okay, so let me just directly pick you to the correct answer. Sulfur as the highest. I guess this is correct. What you think? Sulfur, selenium, and then oxygen. Sulfur, selenium, and oxygen. But I don't see anywhere sulfur, selenium, oxygen. What graph is matching with our sulfur with maximum? Okay, so D is the correct answer, I guess. None of the graph is looking correct to me. Okay, magnitude wise it has been asked. C is the correct answer, because there was a very lesser, what we can say, margin between these two, right? So that is why C is the correct answer. Let's take you to another question. Please try to handle all the questions, try to solve all the questions. You will get more clarity about your chapter. Not to start tomorrow. We have your test actually I'm talking about. Total number of isoelectronic species. So you know what? It's very easy question, directly asked from the one of the PYQs, and somewhere I found the importance of this question because it has been asked many times. Okay, oxide has. So let me write their electrons first of all. So this is 8 plus 2, 10. This is 11, 9 plus 1, 10. This is 13. This magnesium 2 plus has 12 minus 1, 10. 11 minus 1, 10. Oxygen positive will be 8 minus 1, 7. Magnesium has 12. Al3 plus is 13 minus 3, 10. And fluorine has also 9. So correct answer should be this, 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 and this, and this. I don't know what should be the correct answer. It's total number, I guess it's 5. 5 is correct answer. Okay. Chalo. Next is, so there are two statements. The first, ionization enthalpy. If you talk about delta H1, it says that decreases across the period, but actually it increases left to right and decreases down the group from top to the bottom. When we come from top to the bottom, it decreases. Now check it out, and I think this is a false statement. Then increasing nuclear charge outweighs the shielding across the period. Yes, Z effective, and Z is greater than sigma if we talk about the same in left to right. It dominates, and that's why correct answer should be one is true, another one is false, which is true. So A is false, R is true. A is the correct answer. Next question, a similar question but an important question, so I came up with this thing also. I personally think one of the question will directly hit from molecular orbital theory, because till now it's been 6 of the shifts have gone, none of the question appeared to me from molecular orbital theory. I guess this could be your chance of attaining this question. I think so, but not so sure about anything. So that's why we are trying to solve all the questions. We'll see how many of the questions will be connected there, but not particularly relying on the questions or whatever the thing which we are right now having in our mind, but we'll rely on the concepts that we know, on the strength of the concept that we know, that we'll rely upon. And take an example of me, guys. I'm right now over here having some acquired 100 questions, taking questions from so many concepts which are frequently asked and the weightage based, and where did I find there are like lesser number of questions from the concept which has been not been asked. So that's what I pick up from, and that is what I think, that it's a perfect mix-up of the questions. We'll try to solve them. We also have their answers. We won't waste too much of our time. And this 100 questions will be completed in coming 1 or 2 or like couple of hours. And that's it for the day. We'll make it sure. Now coming to this question, we have cyanide ion. Cyanide ion has 1 carbon, 1 nitrogen. Okay, what we have to find out, by the way, species which have identical bond order. So I have a shortcut to find out the bond order. Well, first of all, simply write down their electrons. Carbon is 6 plus 7 plus 1 will be 14. Nitrogen has a 7 plus 8 is 15 plus 1 is 14. Then we have oxygen with 16 electron, then with 15 electron, and then with 14 electron. So 1, 2, and 3. 3 things are there which are having identical number of bond electrons and their filling of electrons as well. And I guess they will acquire bond order of 3. Now the one with electrons bond order will be 3 if there are the 14 electrons are there. Next question, the number of species with Square pyramidal structure. Okay, some of the questions might have come from VSEPR theory. Some of the question more will be asked because this chapter is highly important, right? This chapter is absolutely important for all of us. But the more important part is, even more important part is that concept must be known to us, because VBT is a very frequently asked thing. VBT has been asked very frequently from past few months, years, even decade, I must say. So PF5, like me directly take you to the structure of one phosphorus with no lone pair will be having this structure called as trigonal bipyramidal. Br bromine with 8 electrons in there as one lone pair, sorry 7 electron, plus with Br negative it has 8 electrons now, and 1 fluorine, 2 fluorine, 3 fluorine, 4 fluorine, and 1 is fluorine. This is called as square, and then planar, not planar, it is square pyramidal. So this has become square pyramidal. Then IF5, iodine has again 7 electron, 5 are shared. If 5 are shared, 1 is the lone pair. The similar structure will be seen to you like this. What do you think? IF5. Why did they give BRF? Okay, second is something incorrect I made. BRF4 means is one more this, and this is called as square planar. We can't call it pyramidal, we call it planar. But here it is square pyramidal. This is fine. Okay, BRF5, and these are the same only. Then we'll try it for XeOF4 also. XeOF4 has 8 electrons, one is shared like this, another one will be this, and 4 are the fluorine. So this structure is also a square pyramidal. So this is also correct. Okay, this is also correct. But again, this ICl4 minus, I can check out, this is square planar, not pyramidal. It has a structure of square planar. So for the planar it is there, 3 should be the correct answer, and I guess we are going well. Okay, one more question that was not asked in your examination is all related to redox reactions as well. I haven't seen so many redox reactions till now. Some of the questions from disproportionation also came, but I guess that was a direct question belonging to the either P block, or that question was based upon the D block, T and F block, but didn't come any question related to the oxidation states or any particularly balancing of the reaction, which I find is an important funda, important concept, and might be asked in your upcoming shifts. Let's solve this question. Concept is pretty simple, everyone. What we have to apply is just simply the oxidation state must be known of the compound which are undergoing oxidation reduction. This is positive 6, this is positive 2, this is positive 3, and this is positive 3. Simply cross multiply everything, and you must know the n factors first of all. The n factor is 6, this n factor is 1, 2, 2, 3. Simply cross multiplication will lead you to final equation as 6 iron 2 plus 1 Cr2O7 2 minus gives us 6 Fe3 plus as well, plus I'll write it 2 Cr3 plus, because there are two atoms in left hand side. We are not supposed to change these numbers right after cross multiplication, but we can change as many H we can want, like we want to change the numbers of product side. So now we'll do balancing of oxygen. No oxygen is there, we'll simply add 7H2O and 14H positive will come over here in order to balance it, and that is your balanced chemical equation if it was in acidic medium. Okay, so that is your correct answer. You need to add few numbers. What these numbers are X, so this is 14X, Y is the number of chromium, which is 2, and then Z, which is water, so 7. So 9 plus 14, I think 23 is the correct answer. 23 is the best. So that's how easy questions are, and believe me, I also have found this very amazing concept, like very amazingly I found it Sometimes I'm amazed by the fact, sometimes I'm also disappointed by myself. The way JEE is asking questions these days, chemistry is being very flat, very simple. The only shift that threatened student, that was the evening shift of 23rd of January. So the fourth shift was a bit on difficult side. Rest, no, I guess that was 22nd January only. The second shift paper of chemistry came a bit tough, but not all the papers, not all other six shifts were like out of these six shifts we talk about, five were on the easy side, one was there a bit from the moderate kind of questions came, and that too I found very annoyingly came from that concept we usually don't study, something exemplify it, maybe, or like thermodynamics we study about most of the concepts but don't get into the degree of freedom and that concept. Well, that was something came in this exam. But yes, I guess these questions are pretty important. Okay, some of the questions were like this also, but not some, just a single question I saw was like this, but not exactly. I found this has an important aspect and importance that can come in your exam. We have, I guess, I have no idea as such, but it could be like your 8th or 9th question right now we are solving, or probably 9th or 10th. Question is simple, that P is converting to Q, Q is converting to B, and B is getting into D. And just using the information, what you have to find out is D to P or D to P. So how can you go to D to P? So you can go to D to P by just simply reversing some of the equations. Okay. So what you have to do is just simply write it. D to B, then B to Q, and then from Q to P. So if you add all of them, okay, so they will be cancelled out. Like Q is cancelled here, B is cancelled here. This will directly be giving you D is in equilibrium with P. So now here it has Kc of K equilibrium is 1 by 10. No, not 1 by 10, 1 upon 0.01, 100. K equilibrium will be 1 by 2. K equilibrium will be 1 by 10. Adding all, then overall K equilibrium will be net. It's product of all of them. So 100 into 1 by 2 into 1 by 10. So it will be coming up as 5. We have another question. Equilibrium constant for this reaction is 100. Then initial concentration of all of them will be, won't take too much of your time. We'll just take the idea how to solve the question. We'll move forward. It's that simple. First of all, in this equation, this is A plus B and is in equilibrium with C plus D. So what we will be doing, we have initial concentration says 100 for all of them. No, it's Kc is 100 and we have 1 molar at initial. 1 molar at initial. Okay, so T is equals to 0. We have 1 molar, 1 molar, 1 molar, 1 molar. Okay, so when we reach to T is equals to equilibrium, we know 1 minus alpha is there. Alpha is dissociated out of 1 mole of anything. 1 minus alpha, 1. This will become 1 plus alpha, 1 plus alpha. How it is 1 plus? Because reactants are breaking, products are forming, and the initial one were there 1 molar. It will be added to the one which has been converted from reactant to product will be added to the remaining number of product. So that's how we write the equation for Kc here. So K equilibrium will be actually 1 plus alpha whole square divided by 1 minus alpha whole square. That is equals to 100. We can write it 10. So you can write it 1 plus alpha upon is equals to 10 times of 1 minus alpha. You just need to solve it, find the alpha. So once you will getting alpha, you have to find out the concentration of D. Concentration of D will be 1 plus alpha, that is equals to 1 point, whatever the value comes. Okay, so find alpha and you'll be getting your answer. Check out the answer. Answer is 8. Answer is B. Yes, so that's what I needed. Now we'll take to the next question. Considering the following equation, 2SO2 plus O2 is in equilibrium with 2SO3 and delta H is given like 190 negatively. The number of factors which will increase the yield of SO3. This question also was missing from this segment, and this is actually your Lee Chatelier principle. So I guess it has a high chance to be asked in your upcoming shifts. This is your Lee Chatelier's principle. So that's why I'm saying just simply practice with me. Don't stress out your mind and overthinking unnecessarily on these things, what will be asked, what not. No, simply try solve everything and just take the like amazement and then this like this everything in your mind itself and how to solve it. Enjoy this process, okay? Enjoy it. So we have this negative energy. So it's an exothermic process, by the way. So in this exothermic process, increasing temperature will decrease the rate of reaction. Increasing pressure, the reaction has a higher number of mole. So where the number of moles is there, in that direction it will go. So this is correct. Adding more reactant will take you to the product side. Adding more reactant will take you to the product side. And then addition of catalyst always helps us to yield the number of factor, which will increase the yield of SO3. So it has no effect of temperature. Catalyst has no effect on equilibrium. Once the equilibrium has attained, it will not affect anything. I think 3 points are right here. Next question, see. A liter of that's why I brought up these questions with, because now till now no question from buffer has come. Like it's a very, you know what, it's not very easy to digest. The 6 shifts were asked and none of the question belongs to buffer solution. That was a weird thing I have seen. Buffer in hydrolysis and pH calculations, these are very important concepts and very lovable concepts by JEE Main, which we have been asked in 2024, 2023 very frequently. But now in this shift of 2025, I haven't seen even a single question from buffer. So what I personally realize is these questions might come in your upcoming shift, but again, may or may not. We are not concerned about that part. Let it come or not. We are not like very much reliable on these concepts only. We have already gone through all the concepts in the chemistry and we know how to perform well. That's what we have to focus about. So that was a question we had. Buffer is being prepared by NH3 NH4 Cl on adding 0.02 of HCl. By dissolving gaseous HCl, the pH of the solution will be what? So first off, you should see that there is some NaOH, which will be not NaOH. We have just HCl. This gas reacts with ammonia and forms NH4Cl. Right, NH4Cl is formed here. So how much is it, by the way? This is your 0.1 mole of ammonia is here, and 0.1 mole was already here at T is equals to 0 when just reaction started. When we'll be reaching to equilibrium, that also will let you know how it will work. HCl was how much? HCl passed with 0.02 mole. 0.02 mole. So what we'll be doing? We'll somehow reach to the equilibrium. So once we reach to the equilibrium, some of the part will be, this is also, this is your limiting reagent, this is an excess reagent. So excess reagent will be there. This will remain up with 0.08. This will be 0. And this will also become what? How much is the removed part? 0.1 plus 0.02. So this is actually equals to 0.12. Now talking about the POH here, because it's a base, we find weak base is given. So we'll be finding out POH is equals to pKb plus logarithm of salt by base. So it will become what? How much is pKb? pKb has been given to us, I guess. It is 4.745 plus logarithm of how much the salt we got. Salt is actually this NH4Cl, which is 0.12 divided by 0.08. This is 12 by 8 is given to us. And then once you find POH, you find pH is equals to 14 minus POH, you'll be getting your answer. Now let's see what is your answer. The answer will be 9075. Do it by your own. Don't be reliable on any of the one, and don't you try even a calculator right now, because tomorrow is your exam. Prepare your body, your mind, your everything. In that way only how the exam is going to come and how we are going to appear in the exam. That's what matters to you. Next question. These questions actually I predicted previously as well, and I saw these questions in this exam very frequently. Like there was a zirconium phosphate of the salt given, or some salt related to MX4 kind of given, and the same questions was there. Same questions, literally same, yeah. So solubility will be given by what? And so this is MX4, by the way. dissociates in its aqueous solution, providing some M ions, M4 positive, and that will be aqueous dissolved part, and 4 of the X minus ions which are also aqueous. Using this data we can find out the value of KSP. KSP will be what? This is as T is equals to equilibrium. This simply mentions solubility, and this will be 4 times of solubility. So solubility into 4 times of solubility raised to power its stoichiometry. And this will be coming up like 16 to 16, 256. So 256 has raised to power 4. So this is how you can find it out. I think wherever 256 is there, that will be the correct answer, and power will be 5. A is the correct answer. No, D is correct answer. Okay, maybe some mistake in D is the correct answer. No work from the graph has come till now. As I told you, there were only few questions from thermodynamics which has been asked in previous 6 shifts. So there is a high possibility that this question may appear this time, but that based upon the calculation of work done. But again, it's an easy question because calculation of work done under PV curve is actually the area enclosed by the graph. So this is the graph. There are 2 processes, A to B, B to C. We are going from A, B, C. So for A to C, we have to find out the whole work done. So this whole work done will be added like this. So what is the area, by the way? So this is the area. It's a parallelogram, and you can also find in 2 ways. One, you take the rectangle and then you take the triangle. So basically this is the area of rectangle plus the area of triangle that we have to find out, and that is the correct answer. Just simply apply the concept and there you get the answer as 48. Right, guys? Next question, standard entropy. Since thermodynamics has not asked too much as of now with the higher weightage, the only shift there where the thermodynamics was there with 2 questions was your shift number 2. Until then, no such questions came from thermo, and specifically topics of entropy is not been introduced till now. A question from Gibbs energy also came in previously in one of the shift. I don't remember exactly, but none of the question appeared as for entropy calculation. So that is one of the question that you must know. Now let's see how do we find out the standard entropy change. Actually this question is again the simple only. It's also the similar kind of question only, because when it attains equilibrium, your Gibbs energy becomes, change in Gibbs energy becomes 0, Gibbs energy becomes constant. If delta G is 0, then you will say delta H is equals to T delta S. Delta G used to be equals to delta H minus T delta S. That is what we call as the Gibbs equation. Using this equation, delta H equals T delta S, and the temperature at which we have to find out this equilibrium will be delta H by delta S. How much is delta H given to all of us? Delta H is minus 550 into 10 to the, okay, no, what is it? By the way, this is the entropy. So delta H is somewhere else, 165 kilojoule, 165 into 10 to the power 3 divided by the change in entropy. Change in entropy is given to us negative 550. Solve it and you will get your answer. Solve it and get your answer. Okay. Next question, please. This question is from chapter solutions. Question is simple, saying that vapor pressure is 512 mm Hg, and that of acetone is this, and acetone has a total vapor pressure of 600. A false statement you have to pick up. I have not gone through the question very carefully. Let me read it again. Vapor pressure of CS2 is this. Okay, that's a pure vapor pressure we have been given. So we have the value of P0, which is 512 mmHg, and that of acetone, this is your P0 of A. Then we also have P0 of B, which is 600 or 344. Then total vapor pressure is 600. Let's say if somewhere we have total vapor pressure, so I don't think it will follow a Raoult's law anywhere. First of all, we haven't given up with a proper information about their composition, so we can make sure if A is your carbon disulfide and B is actually acetone, polar versus non-polar. So do you know what is this mixture all about? This mixture is actually positive deviation from Raoult's law. It's nothing but a positive deviation from Raoult's law. So if something is not following Raoult's law, then that's a positive deviation also. And because there is no attraction between CS2, one of them is non-polar, another is polar, no as such interrelation between them. So I think the CS2 and acetone are less attracted. Less attracted is also called as positive deviation, which is true. So, but we have to find is false statement. A mixture of this 100 ml and this, and with a volume of lesser than 200, because if it is this, total volume should be more than that rather than lesser. It will be more than that. So what's a false statement? Heat must be absorbed whenever we are making this, then heat must be absorbed, which is true. And then Raoult's law is not obeyed, yes, which is also true. The only false statement I find is B. So that question was based on ideal and non-ideal solutions, which you attempted it very well. Now I'll be taking you to the next question, and I'll be trying to cover all of these 100 plus questions, practice questions, very fastly on the board, okay, very fastly, because the way I'm going right now, already it's been half an hour only which we started our class, or just a bit more minutes, but we have finished somehow near 15 questions, even more than that. I think 20 questions have been completed. So taking to you the next question, we'll be having a question simply says that I remember this question came in your IIT JEE exam this year only. I remember this kind of similar concept based question came in this year. The standard potentials at 298 Kelvin for the following half cells are given below. These are the number of half cells given to us. Now we will to consider their given electrode reactions. The number of metal that will be oxidized by this will be oxidized B means by this. So it's very simple that if it has been working, since it's a reduction happening there, can't you see it's a reduction? So this is a reduction. This is actually happening at what? At the rate cathode. It's actually happening on cathode, and these are the reactions at anode. So now considering all of them, so let me just take you to one example. So the very first, let's say this is first, second, third and fourth and fifth. Just simply use them. So let's say for the first cell, how much is the E naught cell? So how to find out whether it will be working or not? The number of metal which will be oxidized. So that means simply where we get the E naught cell as positive. So for first, how much is E naught? Cathode minus anode. Cathode is 1.33 minus 10 reduction potential of anode, that is 0.04. So negative 0.04. So that's how it will be coming up as number of metal which will be oxidized. So I think all of them will be oxidized. Only the one which will not be oxidized is the one which is AU positive, 3 positive. AU, like simply AU. This is coming up as positive. So I think the correct answer should be this is correct, this is correct, this is not correct. No, this is also correct, because 1.33 minus 0.80 will also be a positive value. This is also correct, but this is not correct. And only 3 is the correct answers. Okay, just forget the previous question now, and let's jump to the next question. Let's see the next question. We have, okay, some of the questions I saw exactly from Arrhenius theory as well, where some of the reactions were given, and EA, which is your activation energy, was asked in terms of K. That was the one question I saw. But yes, these kind of questions are also similar and very engaging question we have. So it's saying that when we had the 700 temperature, something would have gone very easily, but at 500 using a catalyst, the rate was the same, and EA is decreased by 30 joule. So how do you find out this value? So how will I do it? Assume that pre-acceleration is the same. Okay, so initially you will write it, some rate will be equals to R1 A1. So A is the same, e to the power minus EA. So EA is something that is actually different. EA1 upon R T1, and this will be R2, rate 2 will be equals to A e to the power minus EA by EA2 by RT2. So that's how what we are given up with, and we have to use it, and then we'll get the correct answer. So let's say if I make it, or using both of them, what we can find is logarithm or ln a2 by a1, meaning r2 by r1. So r2 is how much? So let's say it is the same, only r2 by r1 will be equals to, okay, this is saying that these are same only. So if these two are same, then guys, EA1 by RT1 must be equals to EA2 by RT2. That's simple, and R will be cancelled out. EA1 is how much? And there's a difference given between these two, not exactly, but we have to find out the activation energy, so where it has been catalyzed. So we can do one thing, we can think of this energy as E. So activation energy is E, and it has been lowered in the way of catalyst. So what we'll be doing, let's say the temperature 1 be 700, so it will be written up as 700, and the energy was some bit higher by 30, and then it became E that upon 500. Just solve this equation, you will be getting your answer, that 5 plus 150 is equals to 7. It solve it, and then you will be getting your answer. Next question. So this is from periodic classification of element. Some of the concepts were very much asked in 2024, and it was assumed that will be asked by this time also, but we didn't see such questions. The question I'm right now talking you about is from 13th group. I didn't see so many questions. Earlier there were so many questions on 13th group and their periodic properties that we see in your periodic classifications of the element and P block as well. But yes, some of the another question has been given to us. Oxygen with one electron will be a negative, so delta H1 is the negative value. But second, fluorine will be having even higher delta H. We have a talk about, no, delta H1 has a lesser value of magnitude of delta H2, and most importantly, these both of them will be what? Negative. Okay. Then third is delta H3, and delta H3 is like the most which we get. So delta H3 is actually the most negative value will be getting, most negative, and so delta H3 is more negative than 1 and 2. This is true, and we have to find out incorrect. Delta H1 is less negative than this is false. Delta H1, delta H2 and delta H3 all are negative, whereas delta H4 is positive. Also true. Why? Because delta H4 is one ion is there, no oxygen. So this O negative when takes an electron and forms an oxide ion. This is the process where electron will repel an already existing or containing higher number of electron there. So this is your called as EA2. EA2 will be negative, electron affinity will be negative, and we can say delta H of electron gain enthalpy second will be what? Fourth, positive. So that's what we related with. This is again true. I think delta H is less negative. This is also true, yeah. Less negative was there, not true. I think this is the correct answer, false. Because delta 2 is negative, but delta 4 is actually positive. So that's the correct answer, I guess. D is the correct answer. Let's come to the next question, everyone. We have, considering the all phosphorus acids with us, among these oxo acids, the number of oxo acid with the POP bonds are what? Actually, this question is a bit logical question, I must say. And when we teach oxidation states and something about redox reaction, There also we introduce the concept of this part, like if anywhere where we find the POP bond, oxy bond, wherever the oxidation state calculated, whenever the calculated oxidation state comes exactly equals to the oxidation state which is maximum possible. So something equals to, then oxy bond exists. If the higher oxidation state is of maximum if oxidation state calculated is higher, there will be a peroxy bond, and similarly if it is lesser than the maximum possible, then there is a metal bond in that. Here is a POP bond if it is equals. That's a condition I mentioned in the, and even if you don't know, like know it right now and apply it in your exam. So like let's do it. So we have H4 P2O6. Now we have to find out its phosphorus. So the oxidation state will be 4 plus 2x minus 12 equals to 0. So x comes up as 4 minus 12, positive 4. So this is not a correct answer, very simple. Getting me? So first of all, just find it like that only. So we have H3 P3O9. So in this x will be, this is the x, 3 minus 18, 15 by 3 is actually it is plus 5, which is the maximum possible state. That is maximum possible state also. So oxidation state, so we'll calculate our maximum possible state of phosphorus is actually 5. For phosphorus is 5. So that's what you need to count. I think this is the correct answer. So just count them. We also have 4 minus 16, 12 by 2. This is incorrect. This is H4 P2O5. 4 minus 10, right? 10 minus 4 by 2 plus 3, not correct. And you have 5 minus 20, 15. This is also correct. I think 3 is the correct answer. What do you think? Is 3 the correct answer? Yes. So that is a concept we knew and we used it as an application. Otherwise, you got to know the structures of all the compound and then you can do it. Okay, next question is, next we have identify the incorrect statement of the about the group 15 element. We have to talk about the group 15 elements. That dinitrogen is diatomic. Okay, I remember. So one of the question from 15th group and specifically from group 15 itself came from P block, and the question was quite similar, that why O2 molecule has lesser boiling point than S8 molecule, and the reason was very simple, because of its atomicity size increases and the size lead like that. Okay, so dinitrogen is diatomic and acts like an inert gas at room temperature. Is it true? Diatomic inert, which is true. So we have more common oxidation state as plus 3. This is true. Then we have nitrogen has unique ability to p multiple bond, which is true. Then we have stability of positive oxidation state increases down the group, which is false, because of the inert pair effect it decreases. Nitrogen show a maximum covalency of 6, which is false, because it show only 4 as the final valency. So 3 should be the correct answer. Number of correct statement. No, what are the correct statement? D and E. So where are the D and E? D and E are the false statement. Actually incorrect were asked or what? So incorrect statement were asked. These are the incorrect statement, D and E. Very easy question. Next, total change in the oxidation state of manganese involved in the reaction of K1O4 and potassium iodide in acidic medium is there. It's very simple. If it is an acidic medium, then K1O4 oxidizes I to I2 itself, and K1O4 itself gets converted into MnSO4 plus it big. Okay, the reaction is taking place in H sulfuric acid, dilute sulfuric acid. I2 will be your product. So what has been asked, by the way, the change in oxidation state of manganese, this is plus 7, and then in acidic medium it goes to positive 2. So the change should be what? Change is its n factor, that is equals to 5. Next, which of the following is not opted? Okay, that was the question which we can apply from we also study the same thing in redox reactions as well and in DNF block as well, but this question is typically from D block. So which of the following is not obtained when KMnO4 is heated at 513? If we are heating KMnO4 at 513, what we don't get? So what would you like to see? So K1O4 is already present in its +7 oxidation state, right? Okay, why we are unnecessarily wasting the time? We can know the reaction directly. That potassium permanganate produces what? Potassium manganate, K2MnO4, manganese dioxide, and then oxygen. It's a very typically knowledge or database question. Simply apply answer. This is +6, this is +4, this is 0. It's that simple. Next question is, which of the following lanthanide has the largest atomic radii? What do you think? So atomic radii we talk about, we usually go in this way. You remember? VSEPR and PUMSUM. EU God तब दिए हो यार तुम ये भी लो. It keeps on decreasing. That's what the good part about this lanthanides is. We call this concept as lanthanide contraction, and their size keeps on decreasing when we go from left to the right across the period of whatever they are placed for. So this is your basically atomic radii. This is the atomic number. So the correct answer should be, what should be the largest? I think CE should be the largest. VSEPR and PUMSUM EU got tab diyo yaar tum ye bhi lo, but which is not correct. Largest atomic radii. Why? Okay. Got it. Actually, my bad. This is the radius for Ln3 plus. Now that's where we have committed the mistake. This is Ln3 plus, not for atomic radius. So you have to reconsider the part. We have to visit the NCERT again, and the NCERT has this data. Okay, this is from NCERT. It's simple, but you got to take this thing in your account, and you have to take this part. That yes, question may come, and I have seen so many factual question from biomolecule and specifically this chapter. Correct answer is actually this europium. In alkaline medium, the reduction of the permanganate anion involves a gain of how many electron? Alkaline medium is there, reduction of permanganate. I don't know, but it's alkaline or strongly alkaline. So let's suppose we are having normal alkaline medium. So in basic or neutral or like alkaline medium, its N factor is actually 3, and it reaches to the Mn. 2 plus was there, 4 plus will be there, MnO2. This is +4 and this is +7. So N factor is the difference, which is 3. So what involves how many electrons? I think 3 is the correct answer. 3 is correct, guys. 3 is correct. I think this is very easy and easily understanding. Yes, everyone. So just keep on solving the questions with me. Keep your confidence high, and anyhow we'll be reached to our milestone. Let's finish all the questions a bit fastly. We have correct order of the property in 3D transition series. 3D, you know all 3D. This is the 3D: scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper. We have the property, maybe what is this property? When we go left to the right, scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, and then copper, and then I don't know what is this. Radii? No, radii keeps on increasing, decreasing. There's a variation. First it decreases and then start increasing again. So electrode potential could be, no idea, but wrong, I know. Ionization enthalpy, I don't know whether density is the correct answer or what is it. Okay, this is the followed by density. So now learn it, guys, because as I told you, majority of the questions which are right now being asked in JEE 2025 from DNF block are database. There's another database question we have. I can do anything. I can't do anything because all the properties remaining one have a very disordered manner of their values, and that's why I must say, like, something which is following a regular trend is density. Just know it. Like, going from left to the right, it keeps on decreasing. That's it. There might be a variation at the point of nickel and copper, but they have removed nickel, and that's why the correct answer is this. Next question, everyone. We have choose the correct option for having all the elements fit D10 configurations from the following. Where can you find the D10 configuration? I don't need to just write it simple, that try to do it by your own and you find it by your own. Okay, so D10 you can't get in palladium because this is not even 3D, this is 4D. Oh, but let it be 4D. What we are finding: copper, zinc, cadmium, silver. I think this is correct. B is correct. The correct order of A, B, C, D in terms of wave number observed. You know what is the meaning of wave number? Wave number nu bar is directly proportional to the delta E, the energy gap, because hc by lambda is the statement or is the formula. Okay, try this question, guys. We have to find out delta nu. All the things are given over here. I see plenty of things are there, and it's a difficult question, by the way. I personally find it a difficult question. Can't attend very easily. Somewhere in copper is a Cu2 plus, and with water, like it would have been NH3, then it would have made a square planar complex. But I guess this is tetrahedral. Somewhere we are finding D is the most one. Will directly take you the answer, but it's B. So it is actually tetrahedral. And you all know that delta O is higher than delta T, and even higher, delta Sp is even higher. This is your crystal field splitting energy depending upon in magnitude. So just simply rely on the oxidation states. So this is your +3, +3, and then okay, fine. So only do one thing where you can find the strongest field ligand. This is the strong field ligand, even the strongest field ligand. This is cyanide, will come up to the top, followed by NH3, followed by H2O, and then followed by chloride ion. That's how you have to follow. Okay, the correct answer should be okay. So this question what we are right now having, this has been asked in the previous shifts as well, but I personally think that this is an amazing question we have, and we all must know how to categorize them. So I literally know that I literally took one of the very important session on practical organic chemistry and practical inorganic chemistry and this question is pretty simple. NH4Cl, NH4OH, we know what category of the ions we are talking about. So there we have group 3 are the one whose hydroxides are the precipitates. So the group 3 are Al3 plus. Then we have carbonates are for group no idea, group 4, I get group 5, because group 4 are the one which are producing their precipitate of sulfide in higher concentration of sulfide, because this medium is acidic. No, this medium is actually basic. So lesser concentration, in lesser concentration H2S gas we are passing this no, what we are doing, it is a basic medium, higher concentration will be there. No, yeah, it will try to utilize H positive ion and then we'll try to produce H2S sulfide ion. So this is no doubt group 4. Where you can find group 4 is manganese, I guess, manganese sulfide. And dilute HCl is simple, that is your Pb2 plus. That was it. Next question. So read out this question, everyone. We'll connect back. Read out this question. So we have a test during the detection of acidic radical of salt. During the detection of acidic radical of the salt. Oh, yeah. During the detection of acidic radical present in a salt, a student gets a pale yellow. This pale yellow gives already an idea about bromide ion. Okay, because chloride is AgCl is white, AgBr is pale yellow, AgI is dark yellow. Simple as that. And it has a difficulty in NH4OH solution. And why does it have a difficulty? Because you know what, when silver bromide is formed, pale yellow precipitate is this is solid and it is pale yellow PPT. None of them else has the pale yellow color. Okay, AgI is dark yellow, AgCO3 silver carbonate whitish in color, Ag chloride white, Ag bromide pale yellow. The only pale yellow is this. That is why I'm very much sure it should be the correct answer. Then if you add ammonia in basic solution or NH4OH, it will make a complex of AgNH3 whole twice, and then OH, let it be, or whatever it is, and then an NH4Br will be dissolved there. This is your basically aqueous. This is again aqueous. This is actually soluble. Now it becomes what? Water soluble, and that is why we get this test of confirmation that the precipitate, which was already pale yellow in color after addition of basic medium, basic NH4OH, hydrogen ammonium hydroxide, it starts dissolving. That's the correct answer. And one more thing is being said: when sodium carbonate extract was acidified with dilute HNO3, then AgNO3 solution was obtained. Fine then. So we first went, when sodium carbonate extract was made, so what will be that extract? That will be containing bromide ion, and then bromide ion on treatment with HNO3, AgNO3 solution was added. Fine, yeah. Next is, which of the following compound does not exhibit resonance? Where you cannot find resonance. So it's simple that resonance requires a conjugated system. So double single lone pair is a proper way of resonance we can find, and like this you can go to the resonance. There also benzylic alcohol, we call it benzylic alcohol, directly connected. No, sorry, there is no resonance I see. But the resonance is over here only in between, and this is not no reso of this lone pair. But again, we'll have to check up. There we also have this, and then C2NH2. So the lone pair, this is how it works. The reso is over here. Reso. And the last is CH3, CH2, CH double bond CH NH2. So there we don't have any such system. This is an sp3 hybridized carbon atom. So there is no reso. So I think D is the perfect answer, and it might have been the answer, but internally in the benzene resonance is happening. D is perfect answer. Next is the next question: the increasing order of stability of the ion is. So we have been given up with this these kind of structure. Number one thing that we have to make sure whenever we are comparing the stabilities, I haven't seen so many questions of the stability order till now from GOC. My prediction says that this question may be asked in your coming shift. We have increasing order of this. The one which is neutral with no charge will always be higher stable, and the one with higher number of bonds will be the more stable. And then with this is the order we have to follow. Then the order comes with the one in which most of the elements will be having higher number of elements will be having complete octet, will be the more stable. And then comes the finally offer to the negative charge on less electronegative, more electronegative, positive charge on less electronegative. Then this comes here. Electronegative won't work until unless we see that this carbon has a complete octet of everything. This has a complete octet of carbon, and oxygen also with even a positive charge has a complete octet. 6 electrons were there, 2 were shared, like that. Like that. Maybe or may not be. Oxygen, which is connected to hydrogen, 2 electrons are there, and I think oxygen has incomplete octet here. What do you think? 6 electrons were already there with oxygen, 1 and 2 are shared with the positive charge is there, so only 1 electron, 1 is removed. This 5 plus 2, 7 electrons are there with oxygen. I don't think this is complete octet. So correct answer should be first is the most stable, you all know. Then second should be the next one. First and second we get. So this is incorrect, and this is also incorrect. So out of these we have to decide out, and the correct answer should be 3, 4. So 3, I think this is correct. Third is more stable because the same thing is here, because we have this on this time over this with incomplete octet. Both of them have incomplete octet, so no need to take this thing into account. Incomplete octet, you can directly switch to the one which is more electropositive, which will be having a positive charge, one which is more electronegative, acquiring a negative charge. That's how it works. But B is the correct answer. Then column A and column B are there. A and B are here. We have to find out their effects respectively. So you see that these things are, this one has a lone pair, you can directly apply there. C double bond O, Cl doesn't have any lone pair, and even this group is a, well, no idea. This is activating. Oh, okay, differently we have to make. Okay, this is activating. This is your plus M. This is minus M. This is minus M, this is also minus M. Now check out the correct answer. Activating, deactivating. This first one is electron donating group. Then second is withdrawing group. Third one is deactivating group. And for the matter, it is the same thing which we are talking about here. Then let us take it for D. SO3H is electron withdrawing as well. Minus M group, positive M group. This is positive M, OR. This is the lone pair, directly donation will be happening. This is acceptance. This is minus M. Correct answer is we have electron donating. Yeah, matter directing. We can also call it matter directing about electrophilic aromatic substitution. Electrophilic aromatic substitution, matter directing. Plus M will be electron donating. I don't see any correct answer now. SO3H is what? Orthoparadirecting? No, it's meta only. So meta, then electron withdrawing. NH2 is not electron withdrawing. So I think this is a mismatch we see. But again, what can be done? I must see the correct answer given. So this is halogen is orthoparadirecting, and electron donating group is this. Okay, amide is there. Sulfonic acid will also be like that. So I didn't get. Okay. The question, I incorrectly read the question. I read the question incorrectly. The question is simply saying that where is the correct match you get. So is it matter directing? This is not a correct match. So again, now halogen is what halogen does. Halogen is positive M and orthoparadirecting in nature. Positive M more than minus I. Like minus I is dominant, but still positive M. This is also positive M or electron donating. This is minus M and this is also positive H hyperconjugation. So this is orthoparadirecting is first, electron donating group is second, electron withdrawing or matter directing is third, and this is also activating group. B is the correct answer. That's what we had to make sure. What is correctly matching with the required properties, and that was a good question, by the way. Taking to the next question, the IUPAC name. I have seen a few of the questions from IUPAC naming, but right after that, we didn't see too many questions from GOC, specifically talking about the reaction mechanism part, application of the electronic effects part. We haven't seen so many questions in the previous 6 shifts. Hopefully, question may arrive in the upcoming 2 shifts. There is a question IUPAC naming has been asked, and believe me, it was the same question when some of the students showed us, some of the students attempted this question. What we have to do is just identification of the principal functional group at first. This is your principal functional group, and then this will automatically become a substituent. Now try to pick the longest chain with 1, with 2, with 3. Now 4, 5, 6 can be there, and 4, 5, 6 can be here also. Where should we go? What I should take? But everywhere it has been taken enyl line. That means this has been taken as the substituent part. No, 3, then we'll make it 4, then we'll make it 5, then we'll make it 6, and then comes the substituent. And 3 has the chain with it, so it will become what? So 1 hydroxy H, 1 hydroxy, and 3. There's a bigger, or we can say the side chain is bigger. We'll have to use the brackets here, and it's how many atoms can you see? This will become 1 dash, 2 dash, 3 dash, like that. Wherever it is connected with, this will become 1 dash, this is 2 dash, and this is 3 dash. So how to write it? That sir, this is method prop 1 in, this is prop 1 enyl that we have to write. Enyl or in 1 yl is fine, but no need to over exaggerate it, just leave it like that. Let's move to the forward part, that is number of the atoms present here. 6, we'll make it hexane 1 oic acid. You can also write it hexanoic acid. Okay, we forgot to mention the double bond somewhere, so this will become hexane, hex, how much in? X 2 in, no, 2,4 diene, hex 2 4 diene. You can write it enoic acid, or you can also write 1 oic acid. Or 1 oic acid, or enoic acid is fine. So that's what is the correct name is. I think this will also become hexa, because more than it, I think B is correct, or no idea what was the correct, but 6 is correct. Next is the best reaction sequence to convert 4-methyl 2-bromopentane is, okay, from where? 2-methyl 1, okay, so let me first write the equation so that we can get the idea what we are about to what we are gonna to do. So we have 2-methyl 1-bromopentane. So this is what it look like. 1 2 3 4 5. We have 2-methyl and 1 bromo is here also. Pentane into, we have to convert it into 4-methyl 2-bromopentane. 4-methyl 1 2 3 4 and 2-bromopentane. So this is your bromo. So what we are simply doing is just shifting this part to there. How we can do it, that we have to know. Okay. So I guess we have to use magnesium in ether, so that it will be first making a carbon ion, a ready-made nucleophile, will be attacked by acetaldehyde, hydrolysis. So many things is there. I don't know, man. You have to do it, and then you will come to know. So that's what you can do, or rather than that, you can use a NC triple bond CH, which is actually a nucleophile, will be coming over here and removing this part. So after addition of this, we can do the hydrogen with LC. I don't know what is this LC, but it will give you some compound like this. Fine, then you can create the compounds by your own. You can try naming them, and then you can submit your answer. Okay, no need to worry. Actually the answer are given there. Try and do it for all, and then get the final confirmation. I didn't want to waste your time, that's why I've come up. Okay, next, this is some question from hydrocarbon. I see a compound A on reaction with X and Y produces the major product, the same major product, okay, but different by product of A and B. So the orientation, oxidation of A and B is sometimes zup, yaar, it's boring, yaar. Let me read. Compound A on reaction with X and Y produces the same major product. So what we have to find out is, Okay, answer is given. So KMnO4 dilute, and then KMnO4 this, and then ozonolysis, and what is given. So let me check what the question is about. Oxidation of A. Major product different from products of A and B. Okay, A is there actually. What is the compound? How do you get this compound? First of all, that I have to know. And this will become D double mono. So this is A is something. This has been formed by ends, which is formic acid HCOH. So no doubt this should not be a oxidative cleavage. This should be a like this is not a reactive cleavage. This is oxidative cleavage. So the compound which we can use is either KMnO4 hot concentrated, or you can also use the same as ozonolysis followed by as not by zinc dust but using hydrogen peroxide. This is oxidative cleavage. So I guess that was it. So what are X and Y? Probably this was the question. D is the correct answer, ozonolysis, and KMnO4H plus. And I have now no clue what's going on here. Compound A on reaction with X and Y produces the same major product. So if you compound A is given to us, if it goes the reaction with KMnO4H plus, this also gives the same, and with this also gives the same, which is not correct here, because now I've got it. Why is it not correct, everyone? Because this will not give you A, rather than this will be further oxidized in a strong oxidizing agent, will be giving you H2O plus CO2. Then CO2 is the final product there. So we have to choose the things carefully here. Don't fall for ants and all. We also have B, oxidation state of A. Oxidation of A substance gives you this. Okay. Now I must see that I attempted it incorrect. This should be your HCHO, formaldehyde, which upon further oxidation gives you HCOOH, which we have to stay down until here. So which of the given compound can lead its reductive ozonolysis? I guess reductive breaking of this bond, and will lead to this. So this could be either it could be O3 and then zinc in water, zinc dust and water, ozonolysis, reductive ozonolysis we can do. One part. Next part, can you identify, everyone? Because right now I am not able to identify and I want you people to participate. Okay, give me some hints, everyone. Then X and Y respectively are what? And Y takes it to this compound, and B will be what? What is the given answer is there? Ozonolysis and KMnO4 and H plus. So yes, KMnO4H plus also does the same. Okay, so produces the same major product. Major product is same, but different product by different products A and B are different actually from each other. So if I use it, if I use KMnO4 here under acidic condition, not dilute, it's a concentrated or might be the heat with it. So then this compound will actually be HCOH by itself, and then can produce oxidize to give you H2O and CO2. So that's why it has been said that these two compounds are different. Acidic compound, this is like ozonolysis. Next question we have, choose the halogen which is most reactive toward SN1. So where we can get the most toward SN1, where you can get, so this will give you a positive, this will be give you a stable carbocation, resonance balance by benzene ring. There we have resonance balance, this will be giving a positive charge, resonance balance after removal of this. So again, this is the correct answer. So A. So we are getting A and A. So this is incorrect. This is AA. This could be AA. Then we have third. A cannot give you any reaction. Only this can give. Then B. This is incorrect. This is only correct. And then A, B, this can also be correct. This is correct answer, because the D will be something, this will decide everything. This is 3 degree, this is correct. A is the correct answer. B incorrect, is the correct. Sorry. Bring me water, man. Next question. See the next question, everyone. Number of moles of AgCl will be formed in the following reactions. Okay, so how many of them can give you this? Okay, number of moles of AgCl and lead. That is also SN1 reaction, by the way. So where you can find the SN1 reaction? 3 degree. This will be giving you what? 3 degree. This is correct. This will give you 2 degree. This is also correct. You cannot remove this. You cannot remove this. Why you can't remove this? Because this cannot be, there's a positive charge with this double bond will not be stable, and actually there is a already existing double bond character. So this will give it what? Double bond character. Same applies with this, will give it like the double bond character. So double bond character, DBC, death by chocolate. So the correct answer should be 2. What do you think? So 2 can give you the given reaction. Next question. Now mixed up questions are here in organic chemistry. The major product of the reaction is what? Major product of this reaction will be what? So I have this OH with me. Actually the questions are 100 plus. We'll try to do as much as possible. We can take a break. Meanwhile, we'll again restart our session. By 8 o'clock we'll do the same exercise, and then we'll continue like what we are doing. So the major product of the reaction is what? Major product of this reaction is what? So the medium is quite acidic over here, and the medium is quite acidic. This will be removed by the acid, giving us a positive charge here, and then happens an attack. There happens an attack. Once this is removed, we bring a positive charge. This is a 1, 2, 3, 4, 5 and 6. So now take 6 as a negative charge, this has a positive charge, and then get it attacked over here. So we'll make a 6-membered ring. That ring now has a positive charge on this carbon atom. Okay, where right after this is the correct answer actually. So this will be having a positive charge over here. This positive charge being attacked by water itself at the end. Okay, I think C is, what is it, C or B? Let me see. That's the correct answer we'll be getting. Finally. There is another question, everyone. Let's read out this question first of all. Question is simple. Simple says that there's a molecule we are having I2 and NaOH. We know what does I2 and NaOH do. This is the iodoform reaction. We'll be converting it into, this group will be removed, and this will be the first compound we'll be getting. So more or less this will be the same only, and this only will be converted into C double bond O negative or OH, and then will become OH, and then upon heating, so we know beta keto esters does what? CO2 will be eliminated out, and then this is your COH part, this is your alpha, and then this is beta. So this beta keto acids are actually eliminated out. That's how it works. This will be removed. I think A is the correct answer. It's an important reaction you must know. So whenever this kind of system is given to you, and so these two groups are with the same only, we call it like beta keto esters or beta keto acids. Okay, so they're talking from there. sulfur, this is your beta. So upon heating, this is what happens. This will be remaining down as it is, but CO2 gas will be eliminated out, and this will be acquired with a hydrogen, like that. So one of the very important reaction, everyone. Can I see the correct answer from here? I think A should be the correct answer. A is correct. Next, plenty of good questions we have. We'll try to figure them out and we'll try to write down the answer as soon as possible. We are moving with fastly. We'll try to maintain our pace. We have NaNH2 and this is your C2H2 is an alkyne. So alkyne with the two equivalents of NaNH2 will be, you might be understanding what I'm trying to say, that there's a base actually. So this is something what will be getting over here, okay? And then ammonia gas will be eliminated out, and ammonia gas will be eliminated out. So this on reaction with two equivalent of methyl bromide will be attached with methyl methyl. Two sides of the methyl will be there. So this will be Y, and then H2PD BSO4 quinoline will do what? I remember this is a reduction, but in a what should I call it? In it's okay. We remember it's a linear catalyst. This is linear catalyst. So LC, okay, there it was also written LC. This is linear catalyst. The correct answer should be D. Cis alkene will be formed. Cis butene is the correct answer, D. So I think we have the plenty of good questions here. Everybody, please keep on trying the question. Boost your confidence, maintain your confidence, and win this contest of JEE. We have this methyl group. This is a partial positive group. It will attack there, no doubt. No else option is there. It's a ready-made nucleophile you have, and right after it will become O minus, and then here it will become what? It becomes, this is OH, and this has been attached with CH3 group. Then in next equation, what we are gonna to do is we are getting it reactive with HBr. It will become a positively charged carbocation there, and I think this will be replaced with HBr in terms of HBr. It will be getting converted to, it will come up with Br. Water will be eliminated out. This is CH3. Chakiya. Okay, not like that. It's a SN1 reaction is there. So this will become a, okay, this is the only more stable. I think we are going correct here. This is the only more stable. This will be a more stable carbocation is there, and then it will become a Grignard reagent, and then Grignard reagent HCHO to CH2OH will be connected. So this should be a correct answer, everyone. This is where M minus will be connected. This is your CH3 already. This will be connected to CH2OH. How? HCHO it will be tricarbon, and after hydrolysis you all know the reaction. That is how it works. Let's see the correct answer. D is correct, okay. Glucose, you know all glucose. Glucose is HCN. What does HCN do with all glucose? They will convert all of them into, no. KKK. So we have glucose like this. This is OH. This is H. This is R. And this is CHO. Now this attack of CHO with HCN leads us to the formation C with CN. So C with CN and OH. This is called as cyanohydrin. This cyanohydrin will now attacked by H2O water. So we'll give you what? OH, and then we have COH, we have one H, we have this alkyl group whole. I think we should take this part as an alkyl group because the lower part is not affecting in anyhow. So right after water and then with HI, I think OH will be converted into iodide. We have COH group, we have H group, and we have also alkyl group. So what is the compound which we are getting? Is it alpha methyl carboxylic acid? No, it is hexanoic acid. Hexanoic acid with an iodine also, no? No, isn't it? Okay. No idea. It's so one more carbon is also there, no? What's the correct answer? Okay, HI is something. So that is actually incorrect information given to us. It should be HI with the red phosphorus. HI has a different work to do. We have to use here red phosphorus as also. So that reaction works as a converts it into alkane itself, and then it will be converted like this. All the alcoholic groups will be converted into just eliminated out, and then that's your correct answer. Next question, everyone. Correct match between the item 1 and item 2 is what? So benzene, how is it benzene prepared, by the way? Okay, no, we are preparing benzaldehyde. So benzaldehyde, you know, do one thing. If you have benzene and you do this Getterman-Koch, Getterman formylation reaction, then benzonitrile is there. Nitrile means NO, NH, no, what is nitrile? Cyanide group is there. Cyanide can be converted into H2PDS4, and benzoyl chloride is also there. I think this is correct. HCl will do what to cyanide? HCl to benzonitrile. Cyanide attacked by HCl does nothing but just essential to and analysis. I think this is also correct, and benzoyl is also there. So one is pairs with the R, and second with P, and then comes the benzoyl chloride with directly reaction with this gives you CHO. We all know. So that's a correct answer. Actually, even the naming relations are there. Benzonitrile with SnCl2 and H2O gives you Stefan's reduction, Getterman-Koch formylation, and Rosenman reaction. Very important reaction. Everybody, please have a look on all three reactions, and I'll take you to the next question. You might think that we are going a bit faster because that's what it is needed. We have tomorrow an exam. We'll take a break also from here. I don't want to waste your time, so I'm going a bit faster. Please do these questions with me. Keep on your faster pace ongoing. We have amine, which does not give carbylamine test. What is this test for? Carbylamine test is given by 1 degree amines only. Given by 1 degree amines only. What is it? Let it be aliphatic or aromatic. This is also 1 degree. And this is also 1 degree. This is what? Yeah, this is 2 degrees. So this is the correct answer. It won't give you this test. Number of compounds that gives you Hinsberg test. Do you know what Hinsberg test is? Hinsberg test is with benzene sulfonyl chloride. Then on reaction, the first reaction is pretty simple. It's an SN2TH reaction where whatever the 1 degree and 2 degree amines are there, they will attack as a nucleophile to the sulfur, and they will form a compound, an alkyl benzene sulfonamide kind of compound. But importantly, the compound itself has a hydrogen atom attached with nitrogen, which is basic, which is acidic in nature, and being attacked by OH negative, its color changes and gives a different kind of color. Its color changes to red, and no, its color changes to blue, and it initially was red in color. So if secondary is used, the color remain up to red only, doesn't have any acidic hydrogen. Anyways, we just figure out where 1 degree and 2 degree can you get. What is this? This is nothing. What is it? Yeah, this is amide. What is this? This is 1 degree, correct. What is it? 3 degree, incorrect. What is it? 2 degree, correct. What is this? 3 degree, incorrect. What is this? 1 degree, correct. What is this? 2 degree, correct. What is this? No degree, incorrect. What is this? 1 degree, correct. What is this? Amide, no. So tell me the correct answer, everyone. 1, 2, 3, 4, 5, I think. So 5 is correct. Okay, 5 is correct. Now you try this question, everyone. Please try this question. Please try this question. And allow me a moment. Just a moment. I'll come back and join you. But guys, please keep on liking the session. Hopefully you are enjoying it. Hopefully you all are enjoying it. Keep on liking the session as well. So guys, can you see this question? We all can see this question. Where's the pen? Initial step, this will be removed out, N2 positive, Cl negative, and then chromic acid, CrO3 is also in H positive, mild oxidizing agent. What we are having right now, NH2, NaNO2 H positive will make it. This is diazotization reaction. Now, after leaving N2 positive, this will become a positive charge. So this is 1, 2, 1, 2, 3, 1, 2, 3. So it's a pentavalent ring also can be formed there. I have the sequence over here. So first of all, it will be converted to NaNO2 HCl. Okay. For initial stage, it will give you OH only, right? I forgot it. It's not aniline. This is 1 degree amine, and that will be giving you. And the first step itself, this will be removed with N2, and then it will be acquired with OH group. Then this OH group in presence of this will be oxidized, and being attacked by benzene may attack it. This is the group, right? So where can we attack it with? We have the chromic acid here. Sorry, John's reagent, CrO3H positive, converting into carboxylic acid, and then with H positive. What is this carboxylic acid doing? Okay, we'll take a break. We'll see it later. Okay. Know the slide number 127. I'll come back and I'll revisit. Okay, let's not waste the time. Let our session go on. We'll come to the next question, then I'll think what it was. Okay. By the way, A is given the answer, no? No idea, man. Okay, next question, everyone. We have another question. Glucose with HI glucose with bromine water, glucose acidic anhydride, glucose nitric. Okay, nitric acid is a strong acid, so it will make you gluconic acid. Okay, saccharic acid is gluconic acid, I think, is the one at the top of it. It will be having COH group. Okay, and glucose with HI will give you hexane with direct phosphorus and HI. So the first is the answer is fourth. Then B, probably the gluconic acid. Then we have glucose actually will have the saccharic acid, and acetic anhydride, it will form an acetate. With anhydride it will make an acetate. OH group of the will so how many OH groups are there? 5 OH groups. That will give pentaacetate. Can I see the correct answer? Absolutely, A is the correct answer. Total number of negative charge in the tetrapeptide glu S or TYR. So first you all must know about all the because these are important, and I've seen so many questions from biomolecules specifically, so I would like to recommend you, so just please read out all the these acids, their structures. We call them amino acids. Their structures are very important. Okay, so this is what you have to cover it from your end, and then let me give you the correct answer of this question. So we have set of molecules here, and glycine, gluconic acid, glutamic acid, aspartic acid, and so wherever you added, we have made a peptide bond here. This is your peptide bond, CO and H2. CO from one, another will be losing its NH2. Another peptide bond, and another is here. It's been asked how many, and the pH is given to you 12.5. So I just have to think, if there are 4 number of amino acids, so there will be like 3 peptide bond. 3 peptide bonds will be used. If let's say there are 3 peptide bonds used, one COH from one will be left, and another will be having an NH2 group. So like this is having COH group, this will be having NH2 group. One COH will definitely be there. Now we have to find out how many of them will be having another COH group. So when I talked to you about glutamic acid, there will be having a COH group. Aspartic acid will be having a COH group, and then comes your tyrosine. I guess this is also having COH group. So this is how we have to find out. This all will be converted into 3 minus. So 3 minus is the correct charge. 3 minus is because of the all were existing there. And one is the phenol also. Check out everyone, this is phenol. This is the beauty of the concept, that this will also be acquiring a negative charge. 4 should be the correct answer, I think. Next question is from practical organic chemistry, POC, practical organic chemistry. Nitrogen, how do we find out the nitrogen? I remember we form its ferrocyanide called as Prussian blue. Sulfur forms a something which becomes blood red. Okay, this is for sulfur. This, when comes in contact with S2 minus, forms a complex of Na4 Fe CN5 and 1S NOS is there, and the color of this is actually violet and identifiable. Next is phosphorus, forms phosphomolybdate, ammonium phosphomolybdate, a complex, and halogen also. Now what is left, by the way? Halogens are reactive with AgNO3 to giving AgCl is white PPT, AgBr is pale yellow, AgI is dark yellow. Precipitates are formed like this. A is correct. A complex of iron and cyanide has treated with suitable reagent produces a precipitate of Prussian blue. I know the formula very well. and we have just gone through it very like practical organic chemistry and practical organic, because there are 2 chapters I told you on this channel, very amazing channel. There's a playlist. Those who have gone under it, they can know it. What is this reaction about? First of all, iron 2 plus, let's say iron sulfate is there, and you are making it to be reacted with K4F KCN in excess. This is a complex form, K4Fe CN6 plus K2SO4. This on reaction with FeCl3 forms Fe. This is Fe3 plus, so total 4, and then FeCN6. This is 3 charge multiplied by 4 multiplied by 3. This is called as Prussian blue. This is called as Prussian blue. The correct answer should be Prussian blue is where. So the question is the oxidation state of iron complex in X and Y. So who is X, who is Y, I don't know. Suitable reagent precipitate is this. The oxidation state of the iron in this complex is X and Y. Y is greater. So Y is this. This is positive 3, this is positive 2, this is Y, this is X. So we have to find out 2Y by X is equals to. So X will be cancelled. Y is the correct answer, 3. Easy question. So keep yourself motivated, everyone. Try solving all the questions. I remember, I don't know which shift we are talking about, but I saw a question on Dumas and Zeldal's method also, and question was quite easy. The question was asked that which gas is eliminated, or like that only. In Zeldal's, ammonia gas is eliminated out, and Dumas N2 gas eliminates out. Everything is given to you, and you just need to do one thing. Just find out the number of moles of nitrogen gas. That's it. How do we find it? PV equals to an RT. So N will be equals to PV upon RT. How much is the pressure? 758 upon 760, which is actually 1 bar only. Volume, how much is the volume? 30 ml into 10 to the power minus 3 liter. PV upon nRT. nR, R is what? 1 by 12 you have to take. And temperature is already given to you. How much? 287, assume it 300 only, and just solve it, and you can find out the number of moles of N2. So percentage of nitrogen is how much? How many number of moles of N2 you find out into its molar mass is 28 gram per mole divided by the mass of organic compound multiplied by 100. That's the correct answer. Check it out, guys. 19% you'll be getting your answer. Another question from the same. Another question, everybody please try the same concept and same chapter, by the way. This is a practical organic chemistry, okay? Adsorption used for following purification method. Adsorption is used where? Extraction? No. Only chromatography. We have a separate chromatography called as adsorption chromatography. Adsorption is the major rule, major principle behind the chromatography actually. Okay, this is the answer given. Which species has a D2sp3? No doubt these cannot have the one, because there is no concept of where can you find D2sp3? Like, what is the difference between sp3 D2 and D2sp3? If I ask you what is the difference between sp3 D2 and D2sp3, you will simply say that D2sp3 has internally n minus 1 d orbital involved in hybridization, and n this D2 sp3 D2 has n d orbitals participated in the hybridization. The question is, how do you decide it? So until unless we have any complex compound, you can't say it. So first of all, just cut them out using these two. Now apply your mind. This is 4. So 4 will always go for DsP2 or sp3. So it is again not an answer. D is the correct answer. That's how you can get the easily answer out of it. D is the D correct answer. Absolutely. Photoelectric effect, the kinetic energy of the photoelectron increases linearly with what? In photoelectric effect, the kinetic energy of photoelectron increases linearly with what? Even I don't know. So let me see. The formula was h nu minus phi. So kinetic energy is proportional to what? Y is equals to c minus mx. Sorry, mx minus c. So nu is proportional to nu. Frequency, I think is the correct answer. B. B is correct. Next question, please try. Everybody, please keep on trying the question and increase your confidence of this exam. We'll beat this exam tomorrow. We'll see so many questions like this. One mole of P4 react with 8 mole of SOCl2. Give a compound SO2. Blah blah blah. We just need to balance the reaction. That's it. We'll do one thing. I won't suggest you to learn down this reaction, by the way. It's from P block, and that too with the chemical reactions of phosphorus, and this direct reaction with SOCl2 wasn't there. But anyways, you can remember the equation, and not so important because not a part of our JEE Main syllabus. We can switch it. We'll keep on moving, but just learn it. What product does it give it to you? On reaction with SOCl2, it gives you S2Cl2, POCl3, and sorry, PCl3 and SO2. Next, now this is some good question. We see 2 moles of benzaldehyde, 1 mole of acetone under alkaline condition. Use the aqueous NaOH by heating it. X is the measurement of the number of pi bonds in the product will be how much? What is this question all about? I think aldol condensation. 2 moles of benzaldehyde are there. And there is 1 mole of acetone. And basic conditions are there, guys. What it will be doing? Making a nucleophile, then attacking there. So that's the first thing you will be getting, and then introducing one more CHO. Okay. This is again CH3 is there. So that's a compound we'll be getting. So it's an application of what is this? Aldol condensation. Next is nickel tetracarbonyl. Carbonyl, so many things are there, but I know that carbonyl it makes you sp3 only. Copper always forms with strong field ligand specifically, and DsP2 it makes, and then the rest you can check. Wherever strong field ligand is there, you can get D2sp3. Weak field will never give you D2 because pairing doesn't happen like that. So what should be the correct answer? First, second and fourth three. I think B is correct. B is absolutely correct. That's how we'll keep on moving and we'll finish 100 questions very soon, right? Okay, good guys. So Sarvesh Suryavanshi, I literally don't reply to you people first of all, but why am I doing it? Because just letting everyone know, we have exams tomorrow. We are not very free as you are, unnecessarily disturbing the whole class. So I won't entertain you anymore. Thank you for your precious advice, which was not asked and nobody was asking you for. So I'll keep Sarvesh Suryavanshi in timeout for a while as one of your punishment. So I am right now putting you in the timeout for 30 minutes. You realize it for half an hour, staying outside of the class and without texting. Simply watch the lecture and move forward. Guys, I personally have advised students come and attend the classes and enjoy what I'm teaching. Don't enjoy it as a comedy show. It's not a comedy show. You people are watching this live class on YouTube where you can get even very entertaining stuff. Somewhere you go, you find any comedian and you can watch it. It's not a Kapil Sharma show and you're expecting to be entertained by. You're like writing. It's not an energetic class. What energy you're expecting, man? And drink a Red Bull and then stay energized. Just enjoy the class. Try attempting the question. Your exam is tomorrow. Don't teach a teacher like how to teach. Okay. So stay in your limit. I have made you. Anyways, let's see. Which of the following element has a fully filled F in +2 oxidation state? Now let me think of this. Europium 2 positive, I guess. Gadolinium 3+ has D7 configuration, and europium comes before gadolinium. So I think europium 2 positive should be the correct answer. But it's all about the factual part. You see, this is europium 2 positive, and this is 3. I told you, no, gadolinium after 3+ comes to F7. So I think our answer was correct. Lutetium was what wrong with them, yeah? Has fully filled D +2 in oxidation state. Has fully filled. Oh, sorry. Fully filled means F14. We have to find out, right? F14. Then we can easily decide it. Somebody at the end. You going to do ya tum ye bhi low. Low Lu lutetium. At the end of this you have to go. This we are getting with the configuration. So I thought it is like asking for D7. D7 was good. Okay, believe me, this question was given in our previous shifts. One of the previous shifts, this question was there, where europium 2 positive was the answer for D7, and for 3 positive, GD3 positive will be the 4F7. 4F7 is an important number. Learn it. May appear in your coming shifts as well. Now, next question is, which of the following reaction of 1 degree amine is not obtained as a major product? Where you can't get 1 degree amine as a major product? Where can't we get the 1 degree amine, everyone? I think here. What do you see? No, that also will give you 1 degree amine somewhere. Azide ion is there. So this is what this reaction is. This also RCH2NH2. 1 degree amine. This is correct answer. Now see, both of the reactions are the same only. These are the same reactions where they will be producing alkyl isocyanate, which being hydrolyzed will give you RNH2 with elimination of CO2 gas, like that. Okay, these two reactions are the same only. Look at this reaction. If we get this reaction being attacked over here, this will give you NHR, no, OH and NHR. Okay, so that's why it is saying NHR. And then with the So let's say one amino group is there, one hydroxyl group is there, and water has been eliminated out. Then it will what? pH, CH, double bond, NHR, and then upon H2Ni. It's a 2 degree amine we are getting, CH2, NH, and then R. So we are getting 2 degree amine here. It's a 2 degree. C is correct. But CR questions are pretty easy, man. Even you can solve the questions by your own. Okay, and that's what JEE is being doing in previous years. In fact, you pick it from the 2024 and we have come to 2025 and we have seen 6 shifts till now. 5 shifts were pretty easy. One of the shifts was the first day, second shift, evening shift of 22nd of January. We faced a bit of difficulty there, but most of the questions I find are very easy. Okay, let's come to the next question. We have a correct sequence of getting Q from, okay, one and one is has been get Q as the only product from P is, or P to Q you have to come up. And we have to get only this product. Okay, so you solve it by your own, then I'll give you the correct answer. First you apply your own mind. Questions are, I can see that are very much doable. So first of all, if I do H2PT and then I attacked it by C2H5, probably C2H5 may attack an ortho, but no, it will not be, no, it's, I don't think it's working because H2PT or H2Ni can cause you to the cyclohexane as well. Mg in ether, okay, Mg in ether, fine. Aqueous alcohol, good, this will be removed. Then C2H5, then ortho pair, para, both will be the product, but yes, this can go working. Mg in ether, then you can't go, this will be like, it will be Mg ether only every time. And then first if I do C2H5Cl3, then it will attack on only ortho positions of OCs. I think this is better answer because this will be giving you ortho and para. Can I check the answer? D is correct. Yes, I knew it. D is the correct answer. Okay. Some we have an benzoic acid, SOCl2. This will convert it into PHCOCl. This is the Rosenman reaction. Your final outcome will be PHCHO, called as benzoic acid, benzaldehyde. Rosenman reaction. Organic compound C4H9Cl on reaction with Na dry ether. So gives a hydrocarbon which on monochlorination gives only one chloro derivative. Then A is what? First we'll have to see what we are getting, only one product. Okay. So if I make this compound, then how many possibilities are there? I think only one. So I think this is the only compound. If this was connected to chloride, tertiary butyl chloride, I think the correct answer. The order of oxidation state of the phosphorus atom. So we have done it, I guess, if you find out the oxidation states. But this question may come in your upcoming exam. I'm just trying to check how many questions are been left with. Fine then. H3PO2. 4 plus 2x minus 16 plus 4 plus 5 plus 5. What I'm writing is not visible. 3 plus 1, 3 plus x plus 3, 3 plus 1. So correct answer should be H3PO4 at the max, then H4P2O6. I think this is correct. A simple question from Redox section. Next question. Which of the following complex has a possibility to exist as a meridional isomer? Where can you find a meridional isomer? Okay. So does any of the question will come tomorrow in the JEE exam? Of course, that's why I'm conducting this session, but don't rely on these questions only. And okay, you may rely on these questions. You can try these questions. Definitely it's gonna do work for our upcoming 2 shifts. You may find many of the questions and their concept replicating in your exam, but don't do one thing, that is just simply rote learning the answers of these questions, because the concept may be asked over there, but not exact question or exact data or exact answer might not be there, and that will basically affect you. And by this end of this time, and right now when we are having our exam in 28th and 29th and day and a couple of days, I would like to request you, do not unnecessarily involve the revisional part or reading out any chapter that you haven't gone through till now. That will definitely stress you out and also will make you to feel that you haven't covered some part of the entire session. So do one thing, whatever the question is there, try it by your own, bring out the answer. If not right now, pause the TV, pause your video, then do it, then unpause the video, move forward. This kind of habit will help you out of like handling this kind of pressure, and many of the questions will be replicating in your exam, whatever I've been done over here. Which of the following is a possibility to give you meridional? This question also came, FAC and MER, facial and meridional. You must know where do we get the facial meridional? MA3, B3 kind of thing. Okay, so wherever you see MA3, B3. So that's the question came in 2025 as well. Similar question. I think answer should be A. Which of the following cation electrons are symmetrically distributed in T2G and EG? You know what is the meaning of symmetrically? That means like D5 configuration, D10 configuration. So I just can read it out from there that chromium 2 plus will be known, it has a D4. So D5 will be here. So this will be having D5. So D5 will be like this. How do you feel D5? 1, 2, 3, 4, 5, symmetric. How most of the acidic hydrogen given this compound? How most acidic hydrogen you have to find out most. So carboxylic acid, no one can defeat a carboxylic acid, and I think A is the correct answer only. You now don't need to check for others also. Next is the something is given, you will do this, so it will make the compound looking like this. Now I am using NaOH. If I use that, 1, 2, 3, 4. 4-member ring is not good, yeah. Do it from here. Take 1H from here, make it to be attacked over. Then this will go, will attack there. So how many members can we see? 1, 2, 3, 4, 5, 6. 6-member ring will be there. And this is a double bond there will be getting. There is, we are having double bond O. That's how it look like. So this has been connected there, and this will be having a so what was the question, by the way? Okay, this is our product, but what was the question? So the number of endocyclic double bond. Endocyclic double bond, how many can you see? 1 double bond is endo and 1 double bond is exo. Exo is outside of the ring, endo is the inside of the ring. One is the correct answer. The number of endocyclic double bond in P, then X plus Y. Okay, P, then X plus Y we have to find out. First of all, we have to find X. What is X? X is the size of the ring present. So size is what? So this is Y actually we are getting, and X is the number, that is 6. That is 1, 2, 3, 4, 5, 6. So like that you have to do. 7 is the correct answer. Okay. So read the question carefully whenever you go and solve it. One more question, similar question. We have some set of cobalt complexes. Spin only magnetic moment absorb the wavelength shorted is. Do you know what is the meaning of this? Is the spin only magnetic moment of the complex that shortest wavelength. You know what is the meaning of shortest wavelength? Wavelength is hc by lambda. Delta E is equals to hc by lambda. So shortest wavelength, if it is the smallest or the shortest, this will become the largest gap. So wherever the largest gap is there and largest splitting must be there, and that happens because of the oxidation state, different number of the ligands. If higher stronger field ligand is there, higher number of stronger field ligand will definitely affect it and will give you more stabilization to the crystal field stabilization energy and more splitting also. To try to identify, I can find cyanide. There is no comparison of cyanide. C is the correct answer. Now in C, if we talk about CO3 positive with a strong field ligand, the configuration is D. Cobalt is 27, so D74S2. It will become 3D6. Now fill 3D6. So D6 will be what? 1, 2, 3, 4, 5, 6. I think 0 is the correct answer. What should I say? Can we check 0 is the correct answer? Next. So there is a whole set of reaction we see. There's a whole set of reaction we see, and we are gonna to make CaC2 react with this. We know the product, which is CH triple bond CH, which is called as ethyne, along with calcium hydroxide will be formed. Then one equivalent of HCl we are using. What is it doing here? I don't know. Then one equivalent of HCl. What will HCl do with CH triple bond CH? Nothing, yaar. It's already basic. Okay. Sorry, yaar. क्या करवा रहा हूँ मैं? This is your what do we call it? अरे भाई, Markovnikov's addition, man. CH2, one equivalent is there. That will become CHCl. Then with Mg in doctor ether, not doctor, it is dry ether, and will make what? CH2 double bond CH MgBr or MgCl. Then it's a ready-made what you have. You're being attacked with CO2. So this is your negative, this is positive. C is the electrophilic center. We'll go and attack by this, and we'll create a O negative. The COH will be the one. After hydrolysis, what we'll be getting? CH2 double bond CH single bond COH. I think A is correct. Or OH. D and A are looking the same, but don't you fall in this game, right? It's a game of all visibility, everyone. You can see that was a very easy question, by the way. It's okay, guys. It's okay, Sarvesh. Will what you are saying is that does any question will come? Okay, that I already replied. I am Sarvesh. I'm sorry. Oh man. Let's see the next question. Keep on practicing, everyone. Keep on practicing. Go it bit fast. We'll try to finish all the 100+ questions here. I have already completed beyond 50 questions. It's already, we see 60+ questions we have done till now. 30 questions will be left right now. What my count has been said. Now we'll go for this question. Which of the following nitrogen is most basic? No need to just go for every single thing. I know it's been engaged in these resonance, so it's always a bad one. Now out of these two, this is a 2 degree, this is a 3 degree, and that 2 is a 2 degree. So I don't know, man. Y and Z are the same only, but I can see from this one Y and Z are the same. How come is he asking us? So any one of Y and Z can become the answer. So let me see the correct answer. 2 degree mean will be the correct answer, but I don't know. What is the correct answer? W. basic strength available is the lone pair of the electron. Nitrogen has more electron density as it is 3 degree and involved in resonance. I think this is not the one we were looking for. Not correct. By the way, okay, yaar, my bad, man. Non-aqueous. Why am I taking it aqueous? If it is non-aqueous, then it is simply 3 degree, 2 degree, 1 degree. But if it is in aqueous solution, in regular way we use 2310. If it is methylamines are there, then it can become 2310, 2130. Rest this will be followed, okay, like that. Now your W is the correct answer. Next question, please. Arrange all of them in increasing order of their ionic radii. Now is this easy question, man, because we all know about lanthanide contraction, isn't it, guys? Lanthanide contraction is La Hafta, not like that. Separ and pump some, you god. And La3 plus is the largest because the size keeps on decreasing. This is size versus Z. Where do you find the correct answer? So La3 plus, say par, pump sum, ye bhi, I think A is correct. Next, we have a question, everyone. Let's look at the question first of video and then try to find out what is being asked. Molar conductivity of K2SO4 to L2SO4 at infinite dilation. So what you have to find out is simply ionize this part. What you will be getting 2 times of K positive and 6 times of Al3 positive. Let's say if I'm taking it's 1 mole, okay, because for molar conductance has been asked, molar conductivity at infinite dilution. Then again plus 3 plus 1, so it will be like 4 sulfate ion, and everything is given to you. Just put the values and get them solved out over here. You will be getting your correct answer. Oh, thank you, man. So now correct answer should be C only. Okay, very easy question. No need to take more time on this question. We'll take you to the next question then. Now we are considering the order against the mentioned properly MgSiAl, this blah 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 blah. Second ionization potential has been asked here. So I think this is incorrect. False. Why? I just decided using this P only. You know phosphorus. Phosphorus has a configuration after one removal it will become S2 and that will become S1. It can be correct also here. Then acidic strength, we move left to the right. Acidic strength, this is true actually. And electron affinity, if we talk about the electron affinity, fluorine, nitrogen, carbon. Actually nitrogen has the lowest one out of all of them, so that makes this statement false. And now do we have any answer 1 and 2nd? So we do not have any 1 and 2nd. The only correct option is option number 2nd. So 2nd you have nowhere here. So the acidic strength is increasing, that's good. But 3rd option we found it incorrect. Carbon, nitrogen, oxygen, fluorine. Electron affinity keeps on increasing, but nitrogen has a stable configuration. I think correct order should be this. So this is what I said. It's a false statement. But again, only 1 and 3 are the incorrect order has been asked. Okay, then it is fine. So I think we are going in the correct direction here. It was asked us that the false statement we have to find out. The 1 and 3 are the false statement here. Okay, how do you want to check it? Ionization potential, ionization energy. Try to write down the electronic configuration, then try to balance the given equation. Phosphorus has P3 configuration. After removal of 1 electron, it will become P2, which is P2 configuration now. And silicon has a P4, 4s2. No, then it will be having a P3 configuration after removal of the electron. So this is a false statement actually. This is incorrect. So that's what I say. So there is a question, everyone. You can think of the question. This has been coming from practical organic chemistry, and with it I would like to take a break from here. I would like to give a 15 to 20 minute break. Enjoy your break, and once the break will be over, we'll join back and we'll take hardly half an hour to finish the remaining number of some 20-30 questions. So it's a It's a like a break time for everyone. If you want to have your lunch, you may have, not lunch, dinner you may have. It's a break time we are now having. So it's a fabulous session we are right now having. Thank you everyone for your participation, and those who haven't liked the session, do like the session immediately. Sir, कोई important formula for tomorrow? Important formulas to as such I can't say, but what I'm bullish about that will be asked tomorrow's shifts. Some question from ionic equilibria for sure. So revise the formulas of buffer solution, solubility product and all, and then this hydrolysis part and pH calculation that may appear. Okay, now allow me a second everyone, I'll come back and join you. Guys, I'm back. So that was some important time we spent for our dinner. Hopefully you all have done it. If not, not a problem. We'll continue from here for half an hour and then we'll wind up the session. We have some number of remaining concepts with us. Along with that, I have come up with some more number of questions. So these are some 100 plus questions, around 100 questions that we have to definitely apply this question what we are right now facing. And this question has so guys, although the concept of borax, you might think that this comes in the S block and is not in our syllabus, but don't think in that way. This is a part of your practical inorganic chemistry. So number of BOB linkages and this in the structure of borax. First of all, let me see how the borax structure looks like. It's Bob, it's Bob, it's Bob, and it's Bob. Then one more. Like that. Okay, so this is connected with one OH group, one more OH group, how many oxygen have I taken here? 3, 4, 7. This is Na2B4O7. Yeah, let me check it, man. B negative OH, B negative OH. Okay, 2 BH will also be there. So they are incompleted with their. This is how the structure look like. OH whole 4. So that's how it look like. Anyways, the question asked was how many number of. This is there. What? Question was how many number of Bob are there. So how many Bob are there? You can count it. 1, 2, 3, 4, 5. 5 Bobs are there. So 5 are your Bob. And how many are BOH? So BOH 4 BOH I can see. Right? Isn't it 4? 4. So correct answer should be 9. Okay. Next question. Which of the following species contain maximum number of atoms in one plane? Okay, in one plane, how many species are having with maximum number of lone pairs? Okay, we have to be very specific, very quick. Well, these kind of question come. This is belonging to VSEPR. We all know VSEPR very well. There should be some shortcut to utilize the VSEPR, just like in XCFI, xenon pentafluoride. In xenon pentafluoride, 8 electrons are there with one more, that is 9 electrons, 5 are shared, 4 are remaining with 2 lone pair. So how do we supposed to write the structure? This has become now complicated. 9, 5 have been gone, 2 lone pairs. So 2 plus 5. So basically this will be like this. And this is a pentagonal this is a pentagon planar structure. Okay, so one lone pair coming out of the and one more is going inside it. So this is how it look like. I think this is the only correct answer because you can't see as much as the number of planar atoms in it. I think there are like 5 these and one this 6 planar atoms are there. First is the correct answer. Then there is a question we have. Delta H1, delta H2, delta G. What is this, by the way? These are the delta H1, delta H2, and delta Eg in kilojoule per mole. So if I don't know what. Okay. Might be this. Might be the ionization enthalpy, and this is your electron gain enthalpy kind of data is given. Electron affinity. So somewhere it is positive. So that element exists as a monoatomic molecule, and so ionization 1 is very large here. Someone which is smaller, this could be your sodium, I guess. So an element which exists as a monoatomic molecule, no it doesn't. Less reactive non-metal, more reactive non-metal, an element that has a strong tendency to lose electron because this has a lesser energy of this belongs to P. First is P actually, and there is only one answer as P, so that is actually wrong. We are committing, might be because of the very fastly we chose the correct answers to pick up with. Okay, man, we were right only. Probably the options we have picked it incorrectly. Second one belongs to P. Second one belongs to P, and that happens only in B option, right? See, B option is there. Very easy question. We have picked it very easily. and rest. This is what kind of phenomenon we know. So everybody please make sure that this kind of technique is called as option elimination technique. Wherever you are satisfied with the given options in just one concept you can apply, then just move forward to the next question. Don't you rethink about it the same question. Don't need to go for the all. Be super specific about something and move forward, and but read them carefully and properly. Next question. The ground state energy of hydrogen atom is minus 30.6 electron volt per atom. The energy of the second excited. Do you know what is the formula of the energy if we are given with the ground state energy? The energy is simple. E is equals to negative of 13.6, which is the energy, or you can also call it like E naught into Z square by N square. That's the formula we use. So this can be find out for anything. Now we have to find out the energy of second excited state. You know what the meaning of second excited state is? N equals to 3, and what we are it is finding for? We are finding it for helium. So helium means Z, we have to pick it as 2. So this will become minus of 13.6 electron volt into 2 square upon 3 square. It's that easy. It's 9 by 4 we are doing. We'll be getting the correct answer as 6.04 electron volt. That's how we do it. Let's move fast. Let's move fast. Let's move forward, everyone. Please, let's move fast. Come on, everyone. Try to solve this question. We have an alkyne. We are getting it reactive with BH3 THF. We know what does BH3 THF do. It does the what does BH3? BH3 with CH3COH. What does it do? So this is actually hydration which we are doing. Simple hydrolysis which we are doing. So our correct answer. Okay, among the product A, B and C, which of them are the same? Okay, let me just write the product, then we can decide it. So this is P, and initially what should I say, one of them is attached with OH group, and then you also have so BH3 THF forms a complex, first of all BH3, and then it is being substituted by hydrogen, and the another one will be attached by and then we also have BD3 THF there. So actually let me just recheck once because I forgot the mechanism, and I remember the reaction works in this way where anyways this is a symmetric, we can add it anywhere. This is connected to BH2 and this is connected with hydrogen. So you know what is happening here is once a complex is formed there and it has been attacked by CH3COH, so what does it make? Makes you pH, and then we'll make this will be like hydrogen coming out of your CH3COH or like OH group from there, and this is your C here, pH, another pH, and then also here hydrogen. But let me see if the all four are not correct, that I know for sure. Two alkynes will be there. This will provide you simply H. CH3COH will provide you what? Simple H. Double bond is there. One more hydrogen is there. Okay, that is happening after adding CH3COH, and then right after doing in H2 and PD, not D2 and PD. So deuterium will acquire one positions of the carbon atom. So this will begin. This is your CHD, and this is also CHD, and this is a PA. So this is actually A. So definitely A is different, not the same. And talking about these two can give you the same product because these two are giving you the, so B and C are giving you the same product. Okay, the reaction is given there, guys. The mechanism is given here. Just try to follow it, and then you can find the correct answer. Okay, we'll take you to the next question then. Let's see the next question, everyone. Okay, so be attentive, anybody, and try to solve the questions as fast as possible in order to get the idea what we are right now doing it. So we have a colorless salt, and at about strong heating gives you a cracking sound with evolution of a dark brown gas. So this dark brown gas, we got the idea, it could be nitrogen dioxide, and the gas turns moist blue litmus into no, let's see, moist blue litmus paper into red. So yes, it is an acidic gas, so salt could be what? The A is the correct answer. Rest of them don't dissociate. Okay, let me write it. they do not dissociate on heating. Well, we know the reaction of lead nitrate. Lead nitrate makes lead oxide, nitrogen dioxide gas, and oxygen gas. And nitrogen oxide is actually acidic in nature because it forms nitrous acid, like it forms nitric acid directly adding H2O in it. HNO3 is formed. All clear, all set? Yes, absolutely, sir. Next question, which of the following has the greater bond? And that is what I'm marking a star. Everybody please have a focus over here. We have not been asked with any kind of question from molecular orbital theory till now. So there's a possibility, there's a huge possibility that with the upcoming 2 shifts, this upcoming 4 shifts, this can be asked. It's a heavy, I'm bullish on this particular thing, which is your molecular orbital theory. Anyways, which of the following is the greatest bond order in its parent molecule? Then its parent molecule, okay? So let's say if I write it C2 also. So that's what is being asked, and the number of electrons you got to find out. So this has a 12 electron and this has a 11 electron. So this is having closer. You got to reach to closer to 14. So this has the higher bond order. This is the bond order. So that is an incorrect answer. So now let's see. I think B is correct. B is correct because B, you will be reaching towards 14. Can I see the correct answer? I think B is correct. That's what I chose. So B, O2 has a bond order of 2. How? Because of the electrons are 16. So every time you reach differ from 14 by 1 electron, your 0.5 of the bond order will be deducted. So let's say if something has a 13 electron, so it's 1 electron far from 14. 14 has 3, so it will become 2.5. With 12 electron, it will become 2 with like that, and we have to move. Okay. So like oxygen 16, which has this, after removing 1 electron, it will become O2 positive. So O2 positive has how many electron here? Electrons are 15, sir, getting closer to 14. So it will be increased by 0.5. This will become 2.5. Like that you have to work. And highest for N2, which is 14 electron system. Let it be N2, let it be CO, let it be NO positive. All of them will be having bond order of 3. So what if they will be very tough? Actually, JEE wants to maintain its uniformity rather than reaching toward absurdly difficult exam. No, JEE doesn't do that. That absurdly difficult exam won't be given to you. But there is a possibility that I must say, there is a possibility that it may come as a difficult paper as well. But don't worry, don't be feared, don't be scared. Always feel that everybody has been served with the same table, same food recipe on the table. So don't panic over there. But chemistry, beloved, let me make you believe that chemistry will be easy itself, and just go with a simple preparation. Don't you overthink everything. And I must say that if you have covered your NCERT and the pre-IQs, it's very enough that you are highly confident to solve the chemistry, complete chemistry. But yes, talking to physics and mathematics, that you have to plan by your own, because I have seen that in physics and mathematics, you can't just simply rely on NCERT. It's only possible in terms of chemistry. Taking you to the next question, we have among the following, pick out the elements with very high first ionization energy. So okay, out of these questions, always pick the stable configurations. Okay, or what else can you do? So this has a 4s2 3d5, which is a half-filled stable configuration. This is 4s2 and 3d10, which is absolutely high configuration. So I must say, what should be the correct answer then? 4th and 5th are the correct answer given here. 4th and 5th, oh my god. Anyways, ionization energy increases when we move left to the right, and this is the order of ionization energy given. So that was not electronic configuration based question, but it's more like factual. So factual, so you got to learn it all. Okay. So starting from vanadium, scandium, titanium, vanadium, it is 650 in the range, keeps on increasing. So increasing in this way. Okay, when we reach to the zinc and copper, because as many as number of d subshells are increasing, Z effective keeps on increasing, because electrons do not repel them each other very well, but increasing number of protons can increase the Z effective. That is what the poor shielding of d orbital does. Factual. Next, which one of the following complexes which most likely to absorb the visible light? So now it's something else, man. Okay, visible line likely to absorb the visible line. That means that it will be colorful. So just take the configurations very simply. Scandium 3 positive, zinc 2 positive, we have titanium 4 positive, and then vanadium 2 positive. Now try to write down the number of unpaired electron in that. So this has unpaired electron 0, unpaired electron 0, this has unpaired electron 0, this has unpaired electron, scanning vanadium 4:3, this has an unpaired electron of 3. I think D is the correct answer. What do you think? So that is what we call as DD transition. So whenever a given complex accepts the light, it tries to absorb some of the component of it, makes its electron, which is unpaired, available to shift to the next higher level, which is its T2G to EG, and then comes back, and whatever the radiation it has taken, it radiates. This is the something which has been absorbed. The remaining one comes out of it and gives a very different color called as complementary color. And I have already given you a wheel of the 6 colors with Bohr. The one which has been absorbed, the counter and the opposite to it is called as the complementary color, will be shown by the complex. Anyways, this question was quite easy. The only language based question was here that we had to know that if we have this much number of unpaired electron, then it will be colorful. That was the concept used. Let's come to the another question. The question given up with one of the unsaturated aldehyde with us. MEMGBr is being attacked with. Methyl will come there, attack there, and so the major product will be this. This will become OH at final, and here is the methyl group. That is what it will be giving to you. The next question is that MEMGBr in CuBr. MEMGBr in CuBr we are taking. Okay. I remember this equation now. Now only I realize what happens in terms of CuBr. First, the product will be the same only what we are planning. And the second product which you are getting is methyl attacking upon there. Actually, I don't want to confuse you people, but just want to simply say one thing. I want to say simply add one thing over here, that under these kind of condition, and CuBr is given and magnesium bromide is also there, CS3 magnesium bromide. This magnesium bromide is anyhow stabilized by, and this doesn't give you a this will not give you a thermodynamically stable product, but rather than it will give you, there is a specific part of this reaction not even able to recognize it, but I remember this is a portion or the part of the reaction that we use in Grignard reagent itself, that under this condition of cuprous bromide given to you, make sure this attacks on this alkyl part and leading it to the formation of a minus charge, and then H positive will be given over there. So this is how it reflects to you. This will be going to O negative, and then comes the OH, I guess so. So anyways, as of now, don't unnecessarily get confused. Just simply learn it. Okay. And I'll have to read it what that part of this portion is. Let me check it out once. Na 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 na. Seena se. So CuCl work as a catalyst there, and in that way CuCl also helps to retain that C double bond O bond. So you got to attack it only on the alkene part. Just learn it as of now, na? Otherwise you'll be getting confused. I won't basically go for further deep clarification of the same concept which you are right now facing. My suggestion is just learn it as of now in this way only, that the attack will be happening upon the doubly bonded carbon atom, leading to one more carbon atom, and then other will be provided with the H itself, and this double bond keeps on secured. We will come to the next question. Then we have the very beautiful question is the average bond dissociation energy. If you want to ask me the part of this question, I remember some of the questions were asked relatively theoretical point of view from P block itself, from the chalcogen, any 15th group, not chalcogen, we call them pnictogens, sniffing gases. Yeah, so that was your group 15. The question was quite similar from related to the phosphorus and nitrogen, but yes, here is a different question. The average bond dissociation energy of SS and PP are equal. Then what is the value of P by Q? Now, first of all, I have to know what's going on there. What's this question about, by the way? So guys, we know that in sulfur we have this is how the sulfur is there. Crown sulfur. How many bonds can you see? 1, 2, 3, 4, 5, 6, 7. Let me read it. 1, 2, 3, 4, 5, 6, 7, 8 bonds are there, no? So we see 8 SS bond, and so this is actually P is equals to 8x, 8 times of energy, and this will be equals to what? P4 is how much? How does the P4 structure look like? This is how P4 look like. So how many PP bond can you see? 1, 2, 3, 1, 2, and this is how they are connected. But it's a polymeric or what? Not. This is not given to us. So we'll have to check out how many bonds can you see. 1, 2, 3, 4, 5, 6, 6 bonds of phosphorus bonds. No doubt this is this is white phosphorus only, not in the polymeric form as red and black are. So I'll simply take it, and I guess 6 by 8 should be the correct answer, because P by Q, sorry, 8 by 6 should be the correct answer. So answer should come up as 4 by 3. Rest will come in C. So this will become what? 6x. Can I see the correct answer? I think D is correct. Well, that was a good question we had. We have another question, that the product not formed in the reduction, in this reaction, some product will be there. We got to find out which product will not be there. So let's say if we are getting attacked by Br2CCl4, it's an anti-addition. So this is true. An anti-addition will be there. This is also true. But out of these two, we have to check it out. So this is not true. This is not true, and this can also be true. How this cannot be true? Because on one alkene, same side attack is not possible. This reaction is called as anti-addition. The anti-addition of electrophiles takes place, and that's why I'm calling this reaction as next is Na2 positive replaced by Pt2 positive in the complex of this. Which of the following would be would change? So do you know, guys, if we talk about NiCl2 or Br2 or even NiCl4 minus, this will be like it works as a weak field ligand, and because under the weak field ligand the hybridization comes up as sp3, and sp3, its geometry is different over here, it will be tetrahedral. But whenever we reach to the platinum 2 positive or palladium 2 positive, so they belongs to the 4D and 5D series, where there is a strong Z effective working place, even makes the weak field ligands working as strong field ligand. So under this condition, the hybridization will come up as dsp2, and dsp2 hybridization has a shape of square planar. So I personally like the question very well, but I have no clue whether this question can be asked or not. Because so many questions I have seen already on chemical coordination compound, but yes, the questions were definitely from either Warner's theory were there, or some magnetic data was asked, but mostly it was related to the configurational part of CFT, crystal field theory. So always make sure that you are pretty much aware about T2G, EG configurations and all, and taking all the configuration, how to write them, and letting know the formulation of the CFSE, crystal field stabilization energy. That is what you have to focus for. I guess the correct answer should be what? Magnetic moment will be changed or not? Magnetic moment will be changed, sir, because it's a strong field ligand now. So this will be changed. Anyhow, number of unpaired electron will be changed. Geometry will be changed. The geometrical isomerism will be geometrical isomerism and optical isomerism I can't say, because one of them will show GI, one other will show OI. No. Geometrical isomerism will be shown here by cis and trans can be there, no, in this one, and it won't show. And optical isomerism, activity is never, nowhere, because optical activity requires what? At least it should be a chiral atom should be there with the 4 different bonds in sp3 hybridization. Square planar always has, the square planar has no optical isomerism at all, and this has yes, geometrical isomerism. This has no geometrical isomerism because it is tetrahedral, and this has no optical isomerism because of no chirality. So the correct answer, I think, should come up as geometrically no GI. So this is not answer. No, this is correct answer. No, GI was shown there, but optical is nowhere. So I think 1, 2 and 3 will be changed. What do you think? As such, 1, 2, 3 and is not even given the option, man. Okay, sorry, it is there, no? 1, 2 and 3. Wow, yeah. So that's how we do it, very fast. Let's have another question. The monosaccharide present in the following disaccharide is, oh my god, what is this? Yeah, this is like huge. The monosaccharide that is present in the disaccharide, I think this is whole is the same and not same, by the way. This is C1 C4 linkage. This is your C1 and this is your C4. This is C1 C4 linkage, by the way. But yes, we can get this idea that how this structure look like. This top of this will be having a CHO. It's a glucose kind of unit, and the last one will be having CH2OH, and then 1, 2, 3 and 4. Fine. So if I start it from here, this is already bonded. 1, 2. Number 2 is having another downward. So down will be written in the right direction. OH here, H here. Another down here. Sorry, third up is here. This is left. This is right. Going to the third one, we have down. That means right. Sorry, down means right. Down means right. And then this one is having. The next one is connected to the CH2OH, and then what else? OH is not given there. Where is OH, by the way? I think this is the 5-man ring or what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm not sure about the last one, but yes, we'll have got the idea of 2 there. So OH, H, OH, and then this is incorrect. This is incorrect. All of these two we have to pick. This is also incorrect. A is correct here. Next, orange color K2Cr2O7 and yellow color K2Cr4 are respectively due to. So due to one thing only we'll say, because somewhere where there were the compounds, especially I talk about the transition element compounds and transient compound, which are quietly fascinating in color. This color mainly arises due to the mainly due to DD transition. So wherever they have unpaired electron, they do DD transition. So the various thing, where comes the DD transition takes place? In the complexes, DD transition comes from the unpaired electrons. Unpaired electrons DD transition comes from. But whenever DD transition doesn't occur, the another could be charge transfer. Charge transfer doesn't require any unpaired electron, no unpaired electron required. So that's why we say K1O4, K2Cr2O7, K2Cr4, they all are colored. Why? Because of the charge transfer, and that's it. No need to go in the detail of this. Simple do charge transfer in both. Okay. There is another question. We have R2 chloropentane. We have R2 chloropentane. I don't know what is it. We'll make the diagram and we'll understand it. We have monochlorination and takes place. The mixture of the product formed subjected to fractional distillation. Find out the value of X by 2, where X is the total number of fractional distillation obtained. That is monochlorination product we have to find out. But we have to check it out. What is this R2 chloropentane? So chloropentane. What is the R2 here? Okay, got it. This is an optically active compound, first of all. So first of all, you need to find the chloropentane itself. Chloropentane. 1, 2, 3, 4, 5. 2 chloro. This has become what? R. Only R we are taking. Only R we are taking. And that too, we are going to make it what? We are chlorinating it. So where can we find the correct answers? Okay. Now try it with me. This is actually fixed. this is actually fixed. This composition only R we have to take, no? So we are not taking R, S also, we are just simply taking R. So what I'll do is, if you have fix it, and then monochlorination we are doing, so we are just simply taking this. This could be connected to Cl, but this is fixed. We don't have to take it as this star is already there, but can't be taken, it's already fixed. So the product will only R product will be there. What else could be there? It can be there one. It could be there. It can be there. So I'll directly make it. No, yeah, we have to make it. So this could be there. This could be there. Again star. This could be there. Star. This could be there. No star. Reverse steel. So how many can we see? See, yeah, these are 2. This is 1. This is 2. This is 1. This is 1. So I don't know, yeah, man, where are we committing it incorrectly? But I'll have to check the correct answer. There's 1 which we got. This is only how come is it saying 2, by the way? This is having RS, as I told you. And that's the number only. It's 2 is the number that has 2. Okay, I gave it one more basically star somewhere. So where did I get it, by the way? I get it 1 over here. So 1 over there. That is also into 2. That's fine. Why haven't we taken this part into RS? I don't know, man. He is missing it, and it's been written down RNS here. So this is also 2, and this is also 2. So total fragments are there 7, and then 3.5 the correct answer. That is also good. So I guess we were doing it correctly. That way C1 by 2 was asked. 3.5 is the correct answer. Brilliantly. Right, guys, right? I'll take you to the next question now. I'll take you to the next question. Okay, those who are replying me on this segment, let it be. So guys, if you are unnecessarily spoiling the context here and trying to just talk to each other only, I will not entertain you anymore, okay? So I'll just block you unnecessarily. So don't let me do the bad part, okay? Don't force me to unnecessarily do this thing. Just stay over there only, okay? Okay, sir, 3.5 is the correct answer. Okay, we'll come to the next question then. Or this question was actually asked in your this exam also from chemical kinetics, but the one which was asked was related with given data somewhere. I remember the same question was asked here. It's an important question, by the way. But the equation over there was in the terms of somewhere it was like K1, K2, K3 was given, and K net had to derive it. And then we'll have to find out the EA overall, that is your activation energy. Anyways, this question is also similar. If the pre-acceleration factor of this temperature independent and the activation energy of this is zup, 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 zup. So we'll have to find it out, the value, okay? How we can do it? By the way, there's an equation called as ln K is equals to ln A minus EA by RT. That's the equation we read in the Arrhenius equation. It's integrated form. So, sorry, the log form. The pre-exponential factor is the same only. The reaction at T300 will be what? And first order reaction has been given to us. So, that's what it has been given to us. Now, what we should do? Either at 300 Kelvin. So, this ln of K, temperature is also 5 ln T. Oh, I guess that will become A. 25 is also given, minus this and plus this. Well, it's a difficult one, but what we have to find out is the activation energy. So the rate constant depends on the temperature is this. So nice. So I can relate this as ln K is equals to so it's already given C. So you can find out that it has been given ln k is equals to, so this is ln A, this is 25 minus, and it is also saying that it is independent of the temperature. Pre-exponential factor is the independent of temperature. The 25 is this one, okay. So EA by RT will be equals to your 1200 by temperature, which is 300, plus 5 ln T. That's what you have to do, right? And we have assumed that this is minus of this is to take in, this will become negative. So I'm just guessing it. I have no exact clue if the question is going to be in this way or not. I'll just trying it. And then you got to multiply it with the EA is equals to 1200. So this is 1200 R minus. We can take R as 2 if we have to find out the values in calorie. We can take the R as 2. So this will be like calorie, mole inverse, Kelvin inverse. 1200 R minus 5 T ln T into R. This is how you have to find out. Oh man, I should directly reach to the answer first. Okay, we are doing it correct, by the way. So it's giving us correct that d of ln k dt is equals to 12,000 by t square. Okay. So d by dt we have taken 5 by t is equals to a by t square. Solve it, find out. I think this is better. This is a better way of approach, because I was wasting time there. A bit of time was wasted there because we have been given with ln k. So d of L logarithm of d is equals to d of ln k by dt will be equals to this. And that's it. So this is how we have basically eliminated out this term. This term has been eliminated out. Only temperature dependent terms will be there. On differentiation, we can use the differentiation. We can find out whatever we want. We'll take you to the next question, guys. This is the next question from electrochemistry. The question is pretty simple, saying that the conductivity of a saturated solution of silver halide, is this. The limiting molar conductivity of Ag positive and X minus are these. Then what is the solubility product of AgX? So it's pretty simple, by the way, that what we are going to use is, first of all, we'll find out their solubility in terms of alpha. That's what we call them. So conductivity of saturated solution is this, ohm inverse, centimeter inverse. So that is the kappa. Then the limiting molar conductivity of this is this, respectively. So guys, you can find out two things, by the way, from here. One of them is AgX is there, Ag positive X minus is there, and the value of solubility product. Okay, conductivity of the saturated solution is this. So conductivity is given to us. So what we can find out? Okay. Now I got it. Now we can find out. So I know how to find it. We'll find lambda naught first of all. First of all, we have to find out the lambda naught. So this lambda naught is actually, so this is how the reaction actually occurs, guys. AgCl is actually solid, but some part of this will be going to make it AgCl or AgCl aqueous, and that aqueous part gets 100% dissociated to Ag positive and Cl negative. So let us suppose that finally the concentration of these are, let's say solubility is S. So this will also be having a solubility of S. So we know only S moles of this will be basically undergoing for aqueous solution. So what we have to find out is S. So how do we find out the S value? For finding the S, you first of all must know delta naught. What is delta naught of AgCl? Limiting molar conductance will be sum of these two. Therefore, Ag and Br, that is 80 plus 60. So it comes up as 140 Siemens centimeter square mole inverse. Now I'll have to do one more thing, that everything is given over here in centimeters and all, and that is also in centimeter. So I'll make the formula that lambda naught of AgCl has one more formula, that is K kappa into 1000 divided by molarity. Now this molarity is nothing but its solubility, that what has been dissolved in the water. You can use this value of S and you can find out whatever you want. So how are we going to do it? Lambda naught is already given to you 140, that is equals to kappa. Kappa is how much given to us? That is 3.5. 10 to the power minus 10. I hope we are going in the right direction. Then into 1000 upon the solubility. So you will be getting your solubility as 3.5 into 10 to the power minus 7 divided by 140. They use it and you can find out the solubility. So what is your solubility product? KSP will be equals to, sir, GS square. Just square it and you'll get your answer. So I can do the calculation by my own and can provide you the correct answer just using the powers given over here. So I know that this value will be coming up as solubility will be how much? 3.5 into 3.5 is 7. It's 20 given to you. Yeah, I think this is a simpler value as well. So this is actually given to us 20. Not 20, it will be 40. 4 times of this is there, 40. So 40 is there. You know, 25 to 26, 25. I think A is the correct answer. So I've guessed this guy. A is coming up as the correct answer to me, and A is absolutely perfect answer. Everybody, you are rocking now. We all are rocking now. So that's how we respond to the questions. Because 1000 something upon 40 will turn up anyhow into 100 by 4, that is 25. And S square will be 25 to 25, that is 625. So correct answer should be A, the only option with it. That is it. Now we'll be coming to the next question. 1 mole of an ideal monoatomic gas expands against constant. Whenever anything is given as a constant pressure, that means it's an irreversible process. 2 atm to 3 liter, and from this is a zip is happening there. The change in internal energy of the gas during its expansion is what? So against a constant pressure 2 atm, and this is your 2 atm 3 liter, and then we have come to finally is the 2 atm only, and we have come to 13 liter, and also absorbs, this is the work done, we'll find out, and also heat absorbs is 10 kilojoule. So guys, you already know that Q will be what? 10,000 joule. 10,000 joule, 10 kilojoule with 10,000 joule, and we can find out this value by how work done will be P external is 2 atm into delta V. Delta V will be how much? 13 minus 3, and that value comes up as 33, 10, 10 into 2 is 20, so 20 into 101. So this is what it is coming up with, and it's negative of delta V, negative of P into external V. So this is coming up negative of something. So this is like 202 minus 2020 joules. So the correct answer should be 10,000 minus 2020, because you all know delta U is what? Q plus W. So you all know the value of these two, 10,000 minus 2020, 70 something in your answer, and that too in negative. So I think 7980 when, sorry, absorbs. So positive will be the correct answer. B is the correct answer. B is correct. Zoop. I saw one of the question from like previous shifts only, and the question was very similar to this question, and I've come up with this question taking this thing in my mind, that again this question can be asked if it comes with the topic of solubility product. What this question say? This question is quite simple. Solubility of zinc hydroxide in pure water is 3 × 10 to the power minus 6 molar, and what is 6 or minus 8? And not visible. The solubility of this salt, this in the solution at pH equals 12 is what? So first of all, you do one thing. The solubility of this in pure water is this. In pure water is this solubility is given in pure water also. Then the solubility in pH equals to 12. So whenever pH is equals to 12 and we are given up with 25 degree centigrade temperature, pOH will become 2. So concentration of OH minus becomes what? 10 to the power minus 2. So we already had this equation with us, that zinc hydroxide ZnOH whole twice, which is solid actually, equilibrates to form Zn2 positive plus 2OH negative, aqueous and aqueous, So whenever we reach to the equilibrium, now this condition says that zinc will be solubility S, will be having a solubility of S, that I think we have to find out, and this 2OHS will be 2S, but it is already given with 10 to the power minus 2 molar concentration. So what you have to do is you just simply apply the concept of KSP, because we all know KSP doesn't change, right? KSP doesn't change with this. We will put simple value of KSP. How much is the KSP, by the way? It's given here, guys. KSP solubility of this in water is this. Solubility itself is given to us. So KSP you can find out initially. So KSP will be how much? If this is S, this is 2S. 2S is S square is there. So it will be 4S cube. So 4 into 3 into 10 to the power minus 6 ka whole cube is the solubility product. So that is 27 into 4. 7 चौक 28 2 4 2 2 10 108 into 10 to the power minus 18. So this is the same value. The KSP initially will be the same. This is S multiplied by this is your 10 to the power minus 2 into raised to power whole square, and this is equals to 108 into 10 to the power minus 18. You just solve it and you'll find the correct answer here. Not a very difficult question, but yes, can be difficult in terms of calculation. Always have your calculations like a calculator. Solve it fastly, you'll get your whatever you want. Because I remember when I was at your time of preparation, the only subject I was very much comfortable in, that was mathematics. Chemistry was not a primary subject to me. Chemistry was never a first subject of expertise or interest actually was to me. But later on with the time, I found chemistry is cool, and I picked the chemistry, and now I'm teaching chemistry very well, being 10 years in the same field, and now being like I have, what should I say, I've coached a lot of students from medical and even engineering backgrounds, and so many things have happened. But now what I'm saying is that chemistry might be very much helpful to all of us, because direct and straightforward questions come, but it can make difficult by applying difficult calculations. So always be very fearless with the calculation part, because mathematics is the mandatory subject that we have to know and we have to take when we are going for the engineering background and engineering field. So guys, calculation is not a concern to all of us. That was it, that we made it very well. Now I'll take you to the next question that says that how much amount of NaCl should be added to 6 grams of water to decrease the freezing point by 0.2. Another easy question. So I'll simply write the answer. How do you do it? Just make delta TF is equals to I into KF multiplied by molality. So how much is the I? I for NaCl is actually taken as 2, because NaCl is a strong electrolyte. KF is of water, which is already given to you 2 into molality. Molality, how is it calculated? How much amount? So we'll take it x gram divided by 600 gram of water. Sorry, moles first of all we have to find out. For NaCl it is molar mass is 58.5, 1000 divided by molar mass, mass given of water. You just solve it, guys. This value is equals to 0.2. You just solve it and you will get the value of x, and x is your actual answer that has been asked in this question. Can you find x? Because yes, I can. Let's come to the next question, everyone. Now only a few questions are left. We already have covered 100 questions still here, as I can count by my own. But yes, a few more have been left, and that I also try to cover up. 20 moles of an ideal gas at 300 Kelvin temperature thermal contract with the surrounding is compressed isothermally and irreversible from 5 to 1. And in this process, the change of entropy with the surrounding in calories is what? And that's C. You got to find out only delta S of system. That is exactly equals to delta S of surrounding. That's the only difference between system and surrounding as of now that we can see. So because they are in thermal contact, their temperature is the same. So you know, Q reversible by T is the same, will be the same. First thing is 20 mole of this, and in thermal contact surrounding is the isothermally we are conducting it. So you know what isothermally what we have to apply is the general formula of identification of delta S is for an ideal gas, right? An ideal gas undergoing any general process, this formula of entropy change can be written as NCV ln T2 by T1 plus I forgot it, NR ln T2 by T1 or NCV ln T2 by T1. I don't know, man. Let me remember the formula. NR ln V2 by V1. N CV ln T2 by T1 plus N NR ln V2 by V1. This is the formula actually. This is a complete formula. But you know what we are bringing? K at the rate isothermal process. T1 is equals to T2. So that's why your ln of T2 by T1 will be coming up as 0 only. So you need to use only this part. So what does this part say? That 2.303 or R is 2 calorie we have to take. The logarithm of V2 by V1. How much will the volume we are initially taking? 5 to 1. And reversibly from 5 to 1. So it will become 1 by 5. So just take everything and it will come in negative only. So I think that was it. That is what it has been asked. So we know the every value. Will the answer will come in minus 64 calorie. Okay, this will come up as negative 64 calorie. But this is what delta S for system. This is again we are finding out for system. So now you just make it in negative sign. This will become positive of 64 calorie. That is your answer for the surrounding. Next question, please. The very next question, everyone, please let's have a view. The question says that for a reaction considering a plot, we have ln K versus 1 by T, and given in the figure, if the rate of constant of this reaction at 400 Kelvin is 10 to the power minus 5, and then what will be the blah blah blah, man. This question has come in your examinations previously, and I remember this question very easily. There's a plot which we are given with it, and the constant of the rate of reaction is K 400 K. At 400 K, and then rate constant of 500 will be what? There could be two things that we can use. Ln K versus 1 by T is already given to you. Apply this formula of ln of K2 by K1 will be equals to. So that's what we need actually. So this will be equals to what? This is EA by R, and if you want to use ln, then it is EA by R 1 by T1 minus 1 by T2. And you know what is the slope mean? What does the slope mean? So once we know that ln K is equals to ln A minus EA by RT, so 1 by T, this is actually equals to EA by R. What the value we are given, this is equals to EA by R. So you already know the value of EA by R. Just simply put it minus 4606, and then you can solve whatever you want. No, not just put it positive only. The slope is actually negative. This will be equals to negative of EA by R slope. So then you can find out whatever is needed. Okay, ln. So already rate constant is given to us. 10 to the minus 5. So to put it 10 to the power minus 5. And here what is the x we have to find out. And EA by R is 4606. So 1 by 400 minus 1 by 500. Just simply do it, guys. You will get your answer. It's that simple. But make sure this is ln, not logarithm. Can I see? Okay, I'll done the same. E by R was calculated. Ln of this is to find out. We put the same thing. We find out the values, and it's very simple to find out. It's very simple, everyone. I feel a bit tired, and I think most of the questions we have covered till now. We have another question, everyone. This question is on the passage of constant current through a solution of dilute H2SO, PT electrode, blah 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 is happening. Quantity of electricity that was passed it. Okay, I can let you know, but how we have to find out is this much mixture was obtained actually. Okay, so you know what is the overall, if I write down the overall reaction, so H2O gives you H2 plus half O2. It just simply make it like that. I can use this question in very simplest way. So this is what we are doing. We are simply doing it, the electrolysis, and we have to balance the equation. Unnecessarily it can give us the like wrong values, and we don't do it if we don't do it. So that's what you have to do. The passage of the constant current through the solution with dilute H2SO4 with platinum electrode liberated 336. So let's suppose that we are so what is the electricity passed there, quantity of electricity. So we can do it. Okay, so just simply say, take this thing, this is gaseous, this is another gaseous. So let's say at any time we got anytime this is what we got is this has got V and this will be V by 2, right? So V plus V by 2 is already given to us. V plus V by 2 is already given to you, 336 milliliter. Okay, so that's how 3 by 2, V is equals to 336. So you can find out the value of V will be 112 to 224 ml. So that's one volume which we are getting. And how much electricity is passed, that you can find out using this formula. Oxygen from -2 is going to 0. How many oxygen are there? 2e basically is the electron. If I say for this reaction, electron gained are 2e. Electrons lost are 2. So that means 2 is the n factor and 2 e electrons has been used in this process if 1 mole of this has been given to you. So you just need to find out how many moles of the gas we are getting, and the same way we will be conducting our session. See, again let me repeat the concept. What I'm saying, trying to say that, let's say if it is 1 mole, let's say if hydrogen is 1 mole, so hydrogen 1 mole equals to 22400 ml hydrogen. If so let's say since 22400 ml, which is exactly equals to what, 1 mole H2. So how much does it require? Requires how many electrons? I told you 2 electrons, or 2, you can't write it 2 mole electron. You will have to write how much does it need. It will require 2 mole electrons, which is actually 2 Faraday. The charge will be 2 Faraday. So that's why if I'm talking about just 224 ml, then how much does it require? So it will be like 2 Faraday divided by 22400 multiplied 224. The correct answer will be this Faraday is 96500 into 2 by 100. So that's how you'll be getting your answer, guys. Let me see if we are getting the correct answer or not. So I think the correct answer should be 1390 coulomb. I guess so, 1390 coulomb. Rest of the calculations you can do and see, just like I have done it, just like I have made it, you also can make this question. Hopefully you all are getting what I'm trying to explain. Very simple question was there, and a similar question can be seen in your coming exams as well. Coming exam, which is tomorrow. There is another question, that which of the following incorrect matching of the curve and orbital qualitatively, which of the following has an incorrect matching of the curve and orbital qualitatively? So see, one thing is there in my mind that I can apply anywhere is the number of nodes. If there is no radial node, there is no radial node, it will be definitely S subshell. And which S subshell? 1s or 2p or 3d, anything can be there. There's no radial node. How many radial node can you see? I can see radial node is equals to 2. How many radial node can you see? Only 1. So 1, 2 and 3, p, q and r. Okay, p, q, 2p. So this is wrong because this has 0 node. It has 0 radial node. 3p has 1 radial node. This is correct, I guess. 3d has 0 radial node. 3s has 2 radial node. B is correct. Believe me, questions are not difficult. The only difficulty is, if I find anything which is difficult right now going on with the examination, is our preparation. Because whenever we are preparing for the first part or first shift of this exam, somewhere we lag in confidence, somewhere we might have not covered the whole syllabus for the year. Don't take anything negatively, just try to give your 100%. Just try to be the best in your given 3 hours of your exam. Then once you come out of the examination, then make the analysis, what you have done, how much can you get, what basically where do you lag, what was your limitations that you approached in this examination. If you work on those limitations, this particular thing will make your second shift very better. Second exam, JEE Main second attempt, that is gonna to happen April or in that month, will go a bit better. End of the March, mid of the April, or maybe in the May itself. But yes, that is something that we require. Always implementations of the changes, changing yourself. And what is this here? This is not correct. So 2p, this A is incorrect. P has 1 radial node. This has 0 radial node. So this is incorrect actually. Second is correct. Okay, second option is correct. There is a binary solution that is prepared by mixing equal moles of liquid A and liquid B, and that has a total vapor pressure of 450 mmHg. If the vapor pressure of pure liquid A and B are 520 and C3 and 60 respectively, then the correct statement related to this is what? So what has been given, let me just remind you, it's a binary solution and it's by preparing two things. So equal moles have been there, so let's say nn moles have been taken, so their mole fraction of A will be 0.5 and the mole fraction of B will also be 0.5. So total pressure you can identify. This is also called as Raoult's vapor pressure, or we can say that's Raoult's. How can we call the total vapor pressure in Raoult's terms? So this will be 0.5 multiplied by 520 plus 0.5 multiplied by 360. So this is like divided by 2 will be what? 260 plus 180. So this is coming up as 864 14 1 3 और 1 4 440. Now what my calculation says that if it is coming 440 and it was already given to you 440, then I can see that P real is actually greater than P Raoult's. So that means what does it show? It shows a positive deviation from the positive deviation, means the particles might not be attracting to each other. If you have to prepare the mixture, you have to give it some energy. So delta Vx is 0, true. So this is true, this is true, this is false. You have to require some energy. So A is correct answer. Maybe the A is false statement has been asked. Incorrect statement will be 2. Solution towards the positive division. This is also true. Next, we have chemical kinetics here, everybody. Some of the very good concept of chemical kinetics. Something is happening there. Is 0.1, 0.02 we reach T half is given to over here. And how do we make it, by the way? You know what? I once learned one thing that what did I learn? I forgot it. Not a problem. That T half is directly proportional to original concentration raised to the power n minus 1. Okay, like in first reaction AT equals to A naught minus KT. So half life came up as A naught by 2K. So T half was directly proportional to A naught. So this is a yes, n minus 1. No, 1 minus n I must say, because there it was like directly proportional, A naught 1 minus n. TF is directly to 1 minus n. So do one thing, apply this method. Initially 100 will be equals to original concentration raised to the power 1 minus n upon 0.025. Let's simply make it upon 0. This is 100 upon 50, so this is equals to 2. 2 is equals to 4 to the power 1 minus n. So we can simply write it 2 to the power 2 into 1 minus n. 2. So you can also say that 2 into 1 minus n is equals to 1. So using the formula, n will be equals to what? Half, I think. Isn't it? Half. Then n will become 2 minus 3 by 2 also can come. Two minus 2n is equals to 1. 2 minus 2n is equals to 1. So can I see the correct answer? Order is half. I think we are going it correct. So I think you got to find it out and you will be getting your final value. And let me not disturb you. This is incorrect. This is incorrect. So you can do it by your own. Rest of the things, I think B is given there as a correct answer. B is correct. I know everything was done there. Next question is, 0.805 grams of potassium salt, which is CH2NCO. Okay, twice is diabasic organic reduced, zup is happening. And what is obtained? The molar mass of the acid is what? Was reduced 0.303 gram of potassium was obtained. So anyways, this reaction has to be taken in this way, that CO minus K plus CH2 whole N CO minus K plus. This is your salt, by the way, given, and this is also given to you 0. So you can find the value of N from here. Okay, so this is your 0.805 gram. Was reduced and then 0.2 itna potassium was obtained. Well, I don't know what they are properly doing, but I know from its 1 mole you can get 2 potassium can be good, and whatever the rest of the things might be, not interested at all. So this is what we got. This is 0.323 gram. This was 0.323 gram. But anyways, what we have to find out is molar mass of the acid. That means acid will be H, replace this K by H, and then you will getting the acid. We have to find out its molar mass. We can simply do it by how? See, you can find out the number of moles of K positive. You simply multiplied that K positive by 2. That will be equal to the number of moles of your acid by 1. So first of all, you will be getting your number of moles, by the way, from here. You know the number of moles have this much mass. You can find out the molar mass of the salt, and then you can get the molar mass of acid as well. So that's how it was done. You can check out the correct answer, and we'll move to the next question here. Man, feeling a bit tired. Anyways, yeah, come on, show some josh, Sanjay sir. Maximum number of electrons with this, which can be accommodated. Total shell with 3 nodes, having 3 nodes. Subshell with 3 nodes. Okay. Subshells with 3 node. So what with subshell we are talking about, by the way? Hai bhai? 3 nodes are there. Simply said 3 node. I'm not even mentioning it. So F subshell might be there with 3 node. What do you think? So L is equals to how much? Total nodes are 3. Total nodes is 2 N minus L minus 1. This is L. This is the radial node. This is the angular node. So how much does the total node come? This is total node is simply N minus 1. So total node is 3. N is equals to 4. Fourth shell, we have to find out the number of electron with half. Ms equals to spin vector number is half, which can be accommodated in subshell having total nodes of this. But yeah, this is easy question here. What do you think? This total electron will be 2n square. 2n square is 2 into 4 is square. 32. 32 means 16 with plus half, and 16 with minus half spin plus half spin will be 16 only. That's B is the correct answer then. So guys, whoever is watching this lecture, first of all, all that you have to do is to like the session. because you can see a guy who's standing right now, stand still. From past 4 hours I've been continuously trying to explain all the questions to you, not just the questions, also the concepts behind them, and these are most predicted questions you will be seeing in your upcoming sessions. So let us suppose we have come up with 100 and like say 100 plus questions are there, but yes, every shift of them, like we have 4 remaining shifts and 20-25 questions will be asked. So as per that calculation, we are matching with the number of questions going to appear in the exam. But yes, leaving that thing apart, leaving that thing behind, what we have learned from this particular session is how to apply the concept, what should be the way of confidence that we can apply in the examination and get the best out of your extent what you can do. And this is something that will be very much helpful for all of you. What I've done over here, what we are bringing over here. Now I'll take you to the next question, and we are right now running out of the questions because we have just simple few questions left. Already around 100 plus questions have been done from our side, and now a few of the questions which are remaining will be completing them very soon right in front of you. Do like the session everyone and give me more josh so that next time I'll be coming up with very amazing sessions like this. For the whole 2026 journey, you people can connect with us. Just subscribe to our channel and stay connected with us. I will never let you down, guys. That is my promise. I will never let you down. Stay connected with me. I'll give you my Telegram ID and you can connect with us as well. Okay. So I've shared your link everyone. You can join me on Telegram also as well, and you can stay connected with me. Even if you want to join me on Insta, that also I can provide you. Do let me know whatever the things you are planning and whatever you want to do. Just share your plans with me and I'll be definitely available over there to help you out of any conditions you are in. You want any kind of professional, unprofessional, academic, non-academic, personal, any kind of suggestion you need, do let me know. I'll be helping you out in every aspect. Okay, so I've given you. Now let me continue. So we have a few questions left behind. There's a graph giving for H3O minus an aqua solution at constant pressure. So what's given us to? It has been asked, by the way, which of the following graph describes the correct relationship between H and OH minus and aqua solution at constant temperature? So the H plus and OH minus are exactly equal to each other, and whenever anything increases, the another one should decrease, because the product is actually, this is how it works, the H positive multiplied by OH negative. So this can be H positive, or you can also write it like H3 positive. Both of them are the same. So this product comes up as 10 to the power minus 14. So the concentration of anything increases, the another will be decreasing, and it's a parabolic graph. What do you think? It's inversely proportional graph. So let's say this is y and this is x. So you can say y is inversely proportional to x. Correct should be D. Rectangular hyperbola. कौन बोला? It's hyperbola. कौन बोला? कौन बोला? अपना टाइम आएगा, उछल अपनी राख से तू उच्चा अपने लक्ष्य में, परवाने पास आएंगे, आसमां भी सर उठाएगा, आएगा अपना. Anyways, come. The standard molar entropies for these are given to us respectively, and the reaction is also given to us, and the temperature must be equal to at equilibrium. It's a very easy reaction. Do one thing, you can find out the delta S of the reaction. How do you find it? This is molar entropy of NH3, which is 193 minus sum of these two, half of that of 130 plus 3 by 2 that of, okay, mistakenly I have taken it incorrectly, so half you got to take it for nitrogen 190. For this 3 by 2 into 120, just do it, you can find delta H. Then apply this formula, delta G is equals to delta H minus T delta S. So at the equilibrium, your delta G value will be coming up as 0. Delta G becomes what? 0. Delta G is 0. So delta, you can find out the temperature as delta H upon delta S. That's what your answer is. Check out your correct answer, everyone. Check out the process. It's very easy. That's it. A is the correct answer. Next question. A buffer solution contain 0.4 molar ammonia, 0.4 molar ammonium sulfate. So do one thing, that first of all the concentration of base you have to know. First of the concentration of base you got to know, which is 0.4 molar, and you also know the concentration of ammonium ion, which is double of it. So that will be 0.8 molar. Then do one thing, POH is equals to pKb, sorry, 4.74 plus logarithm of salt by base. Salt is how much? 0.8, base is 0.4. This log 2 is actually how much? 0.3. So this will be coming as 0.3. You add it in over here. 5.04 is the, so the pH will become what? At 25 degrees Celsius, 14 minus pH. So POH is how much? 5.04. Your answer must come up as 8.96. Is there any answer like 8.96? If not, then mark it as correct. So guys, I must accept the fact that questions will be easy in your upcoming exams. You just need to have the confidence that I have. And if you can solve the questions like me, what I'm trying to explain to you all, then you will also be very much eligible and very much comfortable in solving the questions. So that's it, I guess. We have another question. A sample containing the finite number of hydrogen like atom. Finite is there, okay? Electrons make the transition from n equals to 6 to the ground state, producing a total of 10 different spectral lines. And what is the number of difference? What is the minimum number of the atoms that must have been seen present in the sample? If you are seeing the 10 lines, everyone, in a sample, a finite number of hydrogen atoms are there, and from n equals to 6, they are jumping. 1, 6 monkeys jumping on the bed. N equals to 1, 2, 3, 4, 5, 6. Where the electrons are falling from, everyone? Let me know where the electrons are falling from. Where the electrons are falling from n equals to 6 to the ground state. They are falling from there to here. And find the minimum number of atoms that must have been seen present in the sample. But how many number of lines can we see? Okay, we are seeing 10 different lines. So what do you think, what can be the maximum number of atoms that can give you 10 lines? 10 lines, how can we get 10 lines? Okay, if we come to 6 to 1, 6 minus 1 is 5, 6 minus 1 plus 1 is 6, 30 lines can be observed in, no, 15 lines can be observed in that way. But we have to find out only 10 lines. So how many atoms can do it? So I can do that. One atom can do this. 1, 2, 3, 4, 5. One thing can do this. Another can do this. 1. These are the different number of lines I'm making. 2. That's it. This will not be visible. Any other line you want to say? You want to say? This could be, so directly from here to here, and then from here to here. That's 2 different lines that it can make. One of them could be this line. This is already covered. One could be this line, and one could be the one over here. So how many can you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, we have made it too much. Only 10 spectral lines are made there. So let us say one electron jumps from this. This has been, this is something that can be done by only one electron. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The another one can go for 2 only. Second electron. First. Second. So now how many lines are visible now? 1, 2, 3, 4, 5, 6, 7. Then 8, 9 and 10. 10 lines you have to make, and there should be different 10 lines. Okay, so minimum number of electrons that you have to tell. So one is this, another one is this. One can directly come there, 1 2 3 4 5 6 7, and then another one can come from here to here and directly from here to here, that we also have taken. This is your third. 1 2 3 4 5 6 7 8 9 only, which we are right now getting. Okay, 9 we are getting. So how can I make this thing to jump like that? One could come down there, one can fall over here. I think 4 we need. What do you think? 4 at least we need, because that's the basic necessity what we are making. So how many maximum lines can one produce that we have tried to make? So this was some of the maximum lines we made. Okay, 1 2 3 4 5, and then these two, and then these two. So if one is remaining, that somebody can directly jump from there to there. This is your fourth electron. I think 4 should be the correct, and rest we have to check, because I didn't find any answer from 3. So my guesses are my power. This is what I do. The sixth sense of mine always helps me to predict of the correct answer, and that's what I made for the day. Hopefully you are enjoying the session. Hopefully you all are also participating in the same what I'm trying to do. We have the next question for every one of you, that says that conductivity of an aqueous solution of the weak monoprotic acid is this much at a concentration of this. At this concentration, the degree of dissociation is 0.02. Then calculate the value of delta O. Do one thing, and I'll explain this question to every one of you. What does this question say? We also have this kappa with us, which is 3.2 into 10 to the power minus 5 Siemens centimeter inverse. That's kappa. And at a concentration, so we also have the molarity, which is 0.2 molar. Then alpha is also given to us, which is 0.02. Calculate the, or we can say it's 2%. So we have to find out the lambda O. Lambda O will be how much? Ohm inverse centimeter square per equivalent. Okay, it's very easy to find out. The only thing that we don't have right now is so this is the at infinite dilution we have to find out. So this is at infinite dilution that we have to find out, and you can find out the delta at C concentration naught, that will be equals to what? Kappa into 1000 by molarity. So how much is the kappa given to you? 3.2. 10 to the power minus 5 into 10 to the power 3 divided by molarity is 0.2. So you can solve it out, you can find out whatever it's required. It will give you 10 value there to font and a minus 1. So this is 0.32. So your lambda C is 0.32. So do you know what is the formula of alpha? So alpha is actually, alpha is lambda concentration upon lambda infinite dilution. So what we are going to write it down? So this is 0.32 upon infinite, we have to tell it lambda infinite. So lambda infinite will be what at infinite dilution? 0.32 divided by 0.02. So what is it? 32 by 3, I think 16 Siemens centimeter square equivalent inverse. Now let me check out whether any answer. Oh, it's 8 actually. Okay. So what is the mistake? What do you find is the mistake we have committed, everyone? Can I find what is the mistake have I committed here? Because I don't see any either. Molarity was good, everything was good. Yeah, what's wrong with them? So 0.02 was there. 16 is the answer I'm getting. We'll have to check it, by the way. We'll have to check it. So 16 into 10 to the power minus 2. Did I find 16? And I found 32 actually. So maybe there I committed the mistake. Okay. So that is a mistake. I took it. 0.16 should be the correct answer. Siemens centimeter square mole inverse. So if you put here the value of 0.16 there, 0.16 there, I think 8 should be your correct answer. 8. So with that, guys, we have finished with the today's session. I hope every one of you has enjoyed it, and I right now feel quite tired now, and you also people should now sleep. Hopefully you all have done well for the day. Don't now engage yourself too much into study. Now just sleep well. If somebody has a session for tomorrow morning, all the very best, guys. Don't study too much now and just sleep. Take a bit sleep, chill out, guys, because that 3 hours of the exam, that will be completely yours. Nobody is there to steal that 3 hours from you. It's a lifetime thing to you. It's an opportunistic thing to you to prove yourself. Never panic, everyone. There's no end of the life after JEE is just nothing. It's just a hurdle in our life. So just always focus in that way, that if I have the guts to do it, I'll make it done. If not, I have plenty of life ahead. I'll do whatever it takes, but yes, never give up. All the very best to all of you. Now I'll have to leave, and we'll connect with you in my next session, and all the best. But yes, subscribe to us, join us, and always stay tuned. And our Telegram channel is also given in the description. Join that, so that every time we will be connected together, every time anything comes up. Our Telegram channel is also given in the description. Okay, so chali, bye bye.